Devjani, hi, this is Pradeep here. Um, Devjani, can you hear me?
Pradeep sir, Vamsi here. Yes.
Hi, Vamshi. Once Dr. Lopez introduces Addy, I will need screen sharing because I'll be doing a small part of her introduction as well to share a couple of slides.
Sure, sir. Hemant, I hope you are there, or Devjani, if you are speaking, please unmute yourself. Sure, so that shouldn't be a problem at all.
Okay, done. Thank you.
Good morning, Paul.
Hey, good morning, Vamsi, or good evening to you. Vamsi, will you likely stay on for the entire 2 sessions of Algorand and also AI, or will you jump off after a while?
I plan to stay. If anybody is fulfilling the deed, I can drop off.
If anybody what?
If anybody fulfills my role here, I can drop off.
Oh, okay. What is your role?
My role is to take the questions if there are any. Yesterday there were a couple of them. So,
Okay, you're coming in and out. But I think I heard you say
my role
some
is
questions
questions
yesterday.
from the students, if there are any. There were a couple of questions yesterday that were coming to me. So,
Okay, great. Debajani, I'm assuming I do not see that Addie is on anywhere, or is she on a sort of webinar or panelist kind of mode? I'm not sure.
see Addy yet.
You do not, okay. So, are you ready to teach the the blockchain class then, Vamsi?
You are better than me, Paul. I would leave it to you and Pradeep sir here.
Paul will take care of the block and I will take care of the chain.
I will take care of the university.
I'll just check that she knows it's starting. Okay, let me While we're waiting, first of all, thanks for either waking up real early in the West or working with us on a Sunday evening if you're in Asia. So thank you for doing that. This is Paul Lopez. I'm one of the co-chairs for the entire global program we call TiE University, and we're just delighted to have you all participate and continue your learning journey. The boot camps this weekend are intended really to enable you to learn some new capabilities, understand some areas that we're covering this weekend and also the following weekend. And as Vamsi has said in the chat room, if you have any questions related to today's topic, certainly put them in chat and we'll sort of watch along the way. But more importantly, not more importantly, equally importantly, if you have questions about how the TiE Hackathon program is going, anything that you have on your mind, please put those in chat. And we have a couple of folks in Hyderabad, India, who will be able to help with those areas, okay? So feel free, this is meant to be interactive. If you want to turn your video on, especially if you ask a question that'll be useful. I also see in chat that one of our managers in Hyderabad has suggested, after your name, you could add your college or university. It gives us a little understanding about you. If you don't know, one of the many objectives at TiE is to help network. And believe it or not, I'm coming to you from the TiE Atlanta chapter in the US, and we have not slowed down any of our programs at TiE. In fact, if anything, we now have worldwide programs we can tune into, and networking is one of the most important objectives. And it's hard to network when you see only a name in a box. So I invite you, should you choose to participate with a live question, et cetera, for sure, turn it on. But that's another way of making sure that, we've got a lot of things going on, but we'll know who you are and so on. So with that said, I think there are a couple of Vamsi and Devajani. I know you'll watch the chat section, and I'm going to check that our speaker for the day, the facilitator, knows that we are starting. I just sent her a message on Signal, but let me check. And then we'll do an introduction, right? So I know when I talked with her earlier today, there were a few networking issues, but we'll get everything back on track here shortly. How many of you, in fact, here, we're going to start making sure that you're interacting with us. If any of you participated yesterday in the boot camp that occurred, I believe, on the subject of, let me see here. Yesterday's boot camp was taught by SmartBridge on natural language processing. Today, we're going to cover blockchain and AI and how to use them to solve business problems. So it's more generic understanding today, and hope that'll help you, if you're part of our hackathon, deliver more elegant and more innovative solutions. And then you can see over the next few days, we'll continue to add topics in that regard. So Pradeep, rather than me jump in about Addie, if you want to just take charge for a couple of minutes, I will stop share and then I'll be back once I give her a call.
Sure. So good evening to everyone from Asia and probably Europe, and a very good morning to everyone joining in with us from the other side of the continent, so to say. So welcome. I hope some of you attended yesterday's hackathon, and I hope you had a lot of value addition to it. For those of you who haven't joined yesterday and were joining in today, there are two back-to-back hackathons, one right now with Addy on blockchain, and the other one that is on AI and how we can use AI to solve solutions. As you know, the TiE University Hackathon is being conducted to help students like you to get a platform where you can interact with mentors, with professionals who are working with large and small corporations who have business challenges, and you as the future of the world would solve them. So we're looking at each of you as a potential superhuman, like with superpowers of hacking and solving. There are going to be a couple of minor tweakings to the hackathon model, which you will receive very soon by mail. Those of you who haven't registered for the hackathon but have registered only for the boot camps, this is an invite to you to join the hackathon, be part of the brigade, so to say, or the gang, and get to learn a lot from the different facilitators and moderators and mentors that we have from across the globe. The idea is whether you get a solution or no, you will go back home enriched by the different perspectives that you can see from students and your peers from across the world. We have students joining in from almost 15 different countries. So if not anything else, you get the perspective of what competition awaits you when you step out of college and into the real world out there working. So all the best. Those of you who aren't registered, please do register. Give it a shot. There are some business management cases as well, some that require only research from your side, and some of them, of course, are technology ones for which you have mentors that are going on. Apart from this, we also have the TiE Global Pitch Competition, which is for startups based out of campuses. At least a couple of members from the team have to be studying in a college or a university. You can also have a couple of members who are not in the university or college. So if any of you have some brilliant entrepreneurial ideas, please feel free to register for that as well. It's on tieuniversity.org.
Okay, Addie is in another Zoom room and is coming back to this one. So I hope all of you have learned a lot from whatever she's been telepathically sending to you. If you want to put up that first slide, I'll make an introduction and then you can continue. And by then she should be here. So very pleased to tell you that today's facilitator of the topic on blockchain is the program manager with an organization called the Algorand Foundation. Algorand is one of both the cryptocurrencies that has taken off starting in the last 2 years, and also they're an infrastructure capability to be able to do what's called distributed blockchain, permissionless blockchain. There are so many words in the blockchain dictionary today that I think our intent is to do two things. Number one is demystify blockchain for you in that regard, and none better than Addie, who lives in Australia, spent half her life, and more than half maybe, in the US, and now works out of Austria in Europe, to tell you about how to demystify some of the things. Because Addie, wouldn't you agree that there's as much information as well as misinformation about blockchain out there?
Yep, that is definitely part of kind of the conundrum of figuring out anything online, is that there's constantly 65 different answers for the same question, and typically half of them aren't right anyways. So
there you go. There you go. And in that regard, so that's objective one, is demystify, give you some basics, what we're calling essentials of blockchain. She joined Algorand Foundation last year, but prior to that, it actually has been for many years in this whole open source platform arena, and can speak both on the left side or all about analytics and so on. She works with research groups from all over the world, currently working on some of the areas of security, etc., but is going to really take the next hour and a half, 20 minutes to sort of demystify. The second objective is so that you, if you're participating in our bootcamp series, you can use some of these concepts to make a more innovative solution, in as much as the potential of blockchain is vast, even though many of the use cases today are in the fintech area. But I think that they're actually growing in that regard. She might tell you about them. But I'm going to ask my colleague in TiE Coimbatore, Pradeep, to tell you a little bit about Addie that you don't know, which is about her creative side. So he's going to take just another 30, 45 seconds telling you a little bit more about our speaker today, and then we're going to turn it over to her. So Pradeep, all yours.
Thank you, Paul, and thank you, Addie. Thanks to you, I have my 45 seconds of fame. Yesterday, Dr. Paul texted me saying that, can you do the intro to the speaker? And I was excited. I said that, yeah, I would love to, because I work in a creative agency, and she's supposed to be a more creative person. But then somehow there was a confusion and he said he has to take the part. But I think the universe has conspired that I have the opportunity to introduce Addy. So that's Addy for you. I'll start off with an anecdote. When my team was trying to make the posters for the hackathon, they found these images that said Addy, Addy, and then we were really not sure whether this is the Addy that we are talking about or is this someone else. So like Dr. Paul said, she literally has a different side to her, both visually and in the work that she does. Born in Portland, Addy is someone who's on the right side of the brain and the left side of the brain, the creative person and the technology person as well. Works very closely in the open source domain. But something that really interests me is that she works on the new media, primarily pop culture and feminist theory as well. She has included and worked frequently with collectives like Nod Labs, which is basically an international research collaborative dedicated to the merging of open source art, architecture, software, and system. She's also been part of the Free Art and Technology Lab, which is a collective of artists, engineers, scientists, lawyers, and musicians. What an amalgamation of people that you can bring abroad. And then, of course, Deep Labs, which is a group of artists primarily involved in assessing contemporary digital art from women. And I think that brings you the feminist perspective or feminist theory of Addy. I would like to share a couple of work that Addy has done. This one's very close to all of us in India. This was inspired by the Holi festival that Addy saw, and then it was called the Black Hawk Down or Mission. I missed the name, but I'll get that right for you. One more artwork from Addy. This one's very beautiful. This is my handwriting and some more, which basically is talking about I will not download things that I do not know, and I will not download things that could get me into trouble. I think a strong, deep message to the younger generation. This one's from an exhibition called While You Were Sleeping, to show indirectly how drones and our survey are conducting surveillances to all of us when we are sleeping, especially in the Middle East and the countries where there is war going on. This one's basically to represent the different ways in which networking has come into our life, a very modern abstract piece. One more using PCB boards. Addy at work doing the Holi exhibition, Holi inspired art, some other art pieces. This one again inspired by the fact that we are under so much surveillance with cameras looking at us at all ways, making it into a chandelier. And of course the tank, which at least for my generation and Paul's generation is a symbol of repression and how the tank is here. And that's Addy. So ladies and gentlemen, please put your hands together virtually, or if you could put your speakers on and give a good round of applause to Addy. Addy Wagenacht for you. Did I get your second name right, Addy?
Yeah, you did. Congratulations. It's not an easy one to do.
All yours, Addy.
Yeah, thank you so much for that intro. I wasn't anticipating such a comprehensive overview of my artistic practice during this, but one funny tidbit is the one that you posted that shows the handwriting on the wall that says, "I will not download things that get me in trouble." This is actually the login passphrase for a specific lab at MIT, which I was visiting, and I thought it was really a funny thing to say. So I wrote this down, and then I ended up using it for obviously a really large wall piece at a museum in Dublin. And it was posted online, and somebody sends me a message and they're like, "Did you get this? Is this actually from our lab? Because I haven't seen anyone else who knows this phrase, and you wrote it so specifically." And so it was quite an interesting kind of return to something that I had copied many years prior and then put into my own artistic practice, obviously. So I want to get started. Let's see here. I think I have to share my application window, so give me 1 second to put this in Presenter.
While you're pulling it up, Addy, I just want, from full disclosure, I'm a venture capitalist in the US, and we pivoted towards blockchain company startups back in 2019, of which Addy's sister company called Algorand out of Boston is part of it. And I will tell you, we have done extremely well. So Addy, thanks for all the work being done through the foundation and through the blockchain and through Algo as well.
Mm-hmm. Yeah, thanks for that disclosure. So can everyone see my window okay right now? The first slide that just says blockchains?
Yes.
Okay, great. It's funny because with Zoom I have to have it in a different window, so I'm looking at the slides. I can't necessarily look at everyone in the call, unfortunately. So I just wanted to make sure that everyone could see it. I was trying to come up with a really witty title for this presentation because I think that a lot of the talks around what blockchains are or why we should use them are extremely boring and a little bit too complex, and they're not necessarily applicable to anything that is tangible or real world or sort of applies to our own use cases. And so I want to try to give you all sort of a decent overview of what blockchains are, sort of what I'm doing in Algorand, ways to get funding, things like that. And then I want to spend a lot of time possibly on questions, because I found with previous workshops, sometimes the questions are leading to answers more than the answers are leading to more questions, if that makes sense. So I started out obviously in art, and I was doing a lot of open source work. Oh wait, someone's not on mute. So I started out in open source and open source hardware, and a lot of what that is sort of about decentralization and peer-to-peer culture. So things like torrenting videos and movies and sharing files, and the idea that things aren't necessarily how do you say, it's only possible to really distribute and disrupt and innovate if we're sharing information with each other. And so I kind of came into blockchain from like a very non-traditional background in many senses of the word. But I wanted to kind of get into the idea and the realization that I think that there's a lot of information, as Paul was saying, out there about blockchain that is written by mathematicians or computer scientists who are typically PhD students or postdocs. They either haven't left the lab in a very long time, or that information is so misconstrued that it's actually inaccurate once it does make it out to the public. That is to say, in my opinion, I think blockchains can be very straightforward or fairly straightforward if you look at them as sort of a normal person would, and not necessarily from the complexities of a postdoc who might be doing Fibonacci sequences and bonding curves. And so I think anyone who has spent much time around tech or the web sees that there's this growing role of social responsibility. There's a larger awareness of security and privacy at both a personal level and a public level on the internet. And blockchains and things like, if you're aware sort of what is happening right now in blockchain spaces, things like NFTs are considered a really hot trend. So right now, if you go on to any sort of tech blog, people are talking about NFTs, which is basically, ironically, a way to sell art. So it's an intersection of things that I'm doing naturally, but it's becoming part of kind of the larger consciousness. And I think since crypto and blockchain kind of aims to solve a larger array of problems related to these sort of areas that I've mentioned, I think that, and I believe that with the political and social awareness, blockchains can kind of rapidly change the way we think about economies and governments and how we do finance. Everything from wiring money to how we buy something like a house or an apartment can all be disrupted, for lack of a better word, utilizing blockchains. And so I hope that if you have any questions about this technology, I have some answers, and if I don't, we can Google it together. So I do encourage you to kind of drop questions in the chat box, and then as I wrap up the conversation and summary, we can kind of go back and see if we can dissolve those questions into answers for everybody. So the question I generally get right away is like, if I understand what a blockchain is, and it aims to kind of solve specific problems, why is it important, at least a little bit, that I understand sort of what blockchain is? So typically people that work on blockchains traditionally have been people like computer scientists, engineers, sometimes business management, high-level economics, but more recently it's things like economicists and mathematicians who are maybe at a lower level in the sense that they are self-trained. philosophers are getting into it, biologists, hackers, and even students. And so bear in mind this, that sort of the technology is broad and in my opinion is still decently immature considering that it's only been around for about the last 10 to 12 years. And it has the opportunity to create kind of a recipe for success and new models that hasn't emerged yet. So unlike the World Wide Web, which has been, has a lineage of history that has lasted, 30 to 40 years, we're just starting to see blockchain developing in a way that I think can really be utilized and in interesting use cases. So this is a great and exciting opportunity for everyone to get involved. And sort of no matter what you're studying or if you're out of school, there's areas that you can relate to blockchain from either an enterprise level or a entrepreneur level or a student level to sort of identify and dissolve sort of creative, I think, opportunities and problem solving, which wouldn't necessarily be possible otherwise. So this is my favorite image of sort of what blockchain is. When I first got started at a prior organization called Parity Polkadot, people would say, what is blockchain? And my answer was always magic internet money, because that's exactly what I felt like it was. There was all this deep level information that was like highly obfuscated in the sense that I didn't really understand what I was doing when I got into it. So it was a lot of like faking it until you make it. And a lot of the people who were extremely experienced developers were even kind of figuring it out as you go. So I like to remind people that, again, like the blockchain technology itself was invented in 2008 specifically, and it is essentially just a list of records which people refer to who are developers as nodes that connect together to create sort of like the main overriding statement of Bitcoin specifically, which is the first kind of ledger that was invented, was to serve as a public transaction space. So then you might be asking yourself, okay, so what is Bitcoin exactly? And basically Bitcoin was like the first unregulated digital currency with the main goal of creating a decentralized electronic cash without the need of intermediaries. And when I say intermediaries, I mean like banks and ATMs and financial institutions. And it would prevent sort of this larger like double spending problem that is quite frequent and common when you look at things like credit cards and traditional banks. So Bitcoin basically works as a security protocol called proof of work, which I can get to. I can get into kind of more in detail if anyone's interested, but there's two primary kind of layer chains to the layer one blockchain system. And when I say layer one, I like to explain it as a house. So layer one of a cryptographic like blockchain protocol is essentially the foundation. So in the West, it's like you lay the cement, and that has to be laid very well and very efficiently. And you have to look at where the rocks are and if it's earthquake proof and all these sort of things. And then you build the house on top of that. So layer ones are things like Bitcoin, Ethereum, Algorand, Polkadot, Cosano. There's a bunch of different ones. Solanus, they're all layer ones. And then they use different types of mechanisms depending on how that chain was developed. So proof of work is things like Bitcoin and Ethereum. And then proof of stake are things like Polkadot and others like that. And so the big kind of conundrum right now is that proof of work, if you're looking at sort of the tech blogs and stuff, is that proof of work is highly non-environmentally friendly. It uses huge amounts of electricity and is not environmentally friendly because it's typically using electricity, again, like I just said, but with fossil fuels being sort of the main source of how that electricity is powered. So it's essentially kind of burning out huge amounts of natural resources, where proof of stake is a much more optimized, less electricity hungry sort of mechanism for doing essentially the same kind of things on chain. So this is a decision matrix. Like Paul said earlier, I'm working for Algorand, which is this bottom one on the bottom part of the page that says pure POS. This is our logo. So bear in mind that this comes with some how do you say, incentivization. Perhaps it's not the most neutrally presented chart, I will say that. But it's interesting to note that Algorand, we are a PPOS chain, which is basically a pure proof of stake chain, which is not included in this chart, or the other kind of, I would call them brothers and sisters, are not included in this chart. But Algorand specifically solves this attempt to tackle the blockchain trilemma. We use things like unique staking processes, so there's no delegation required. You just need to basically hold algos to contribute to the chain's building mechanisms. And there are other cryptocurrencies that run on Algorand as well. And we're currently working on an ASA, which is the Algorand Standard Assets, which already work on chain, but we're basically looking at developing then like an NFT mechanism, which means that the ASAs are non-divisible. So the pure proof of stake is interesting because it's validating blocks into its chain, and it's seen as, it sees the solution to this trilemma. And the trilemma you can essentially think of as like a triangle where the belief, or prior to Algorand, which was launched in 2019, the belief was that you can't solve all of these things, which are things like security, decentralization, and scalability. So by creating the pure proof of stake, we're basically looking at each block is created to the next one basically by a random selection of people who hold algos, versus in other chains, this is done in a more mechanical way. So it aids to kind of greater scalability. And you can see sort of the benefits of other chains. For example, the argument is that if you look at proof of work, it's very secure, but I would argue that it's actually not as secure because there's been quite a lot of exposures and hacks that have happened to those. And then there's chains like, again, Polkadot, there's Cosmos, Solana, Cardano, these sort of proof of stake chains, which I think are also quite interesting. And I would encourage you, obviously I'm biased because I do work for Algorand, but I would also encourage you to look at the other proof of stake chains, because I think that they all kind of have their own powerful use cases and benefits depending on what it is that you're wanting to build out. So I tried to just go through that really quickly, but I wanted to dive in a little bit into kind of the details about how things work, especially like within distributed ledgers. So when I say that, it's basically a fancy way of saying a distributed database, or even a less fancy way of saying that would be a way that we look at other people's computers in sort of a cluster. So if you have a lot of different computers, that would be considered like a distributed system, for example. Instead of just depending on one person with one computer, you have a lot of computers that are distributed, and that's sort of what you refer to as consensus. And so the idea is that it creates an organization of these things, again, called nodes, that basically allow this peer-to-peer network to form a certain set of rules that are defined by the network, or AKA the blockchain. So, oh, my little fancy thing worked. Okay, sorry. So if you look at like the step-by-step kind of process of how does a blockchain work, or how exactly do you like add a block to a chain? Is it a literal chain? Is it a blockchain? So for each block that is added to a chain, it's literally a chain. Each one I like to imagine as a block across this chain. With a normal kind of blockchain model, you have this, how do you say? There's no authority, so it's looking at the whole network. It's looking at the distribution of all these computers and people to essentially create kind of the next block and agree, aka a consensus, to build this next block and add it to the chain. So it's basically a majority model typically, which is about 51% of all people or organizations that are running these nodes have to create the next block in the chain. So the way that the flow works is that there's a transaction. There's two parties that agree to exchange something like a token, a coin, an asset, a smart contract, for example, an ASA, or an NFT, which again, like I can talk about later if anyone's interested. they'll agree like, okay, I want to take this from you, and you agree that you're going to take it from me. Then basically this kind of agreement will join a queue with other agreements in a verification stage, which will then create, in theory, assuming they're all agreed to, a new block. So this is, again, going back to sort of the consensus idea. The consensus basically, once the majority of computers agree that this is a valid, that all the agreements in the block are valid, it will then create the block. And then the receipt, which is referred to as a hash, but is essentially a unique strand of numbers that is cryptographically validated, is then sent back to the two parties which started it all and all the other parties who had agreements. So each validation, basically you get a unique number or a unique assignment, which then proves that it was written to the new block and then becomes part of kind of the blockchain. So SDKs are interesting also. Once you kind of decide that you might want to work on a blockchain and you're interested in looking at what blockchains support, these are really common programming language that are utilized. Algorand, again, supports the majority of these. So we have SDKs to write to Java, Python, Go, Java, Rust, PyTeal, Teal. And then other chains might use primarily, for example, the majority of other layer 1 chains that I'm aware of and I've used primarily rely on Go or Rust. So there's sort of some like, how do you say, interoperability between chains, in the sense that if you are proficient in certain languages, you can then go to other chains and utilize those. And I also want to talk about kind of, if you have an idea, ways that I think that you can get funding or support for your idea, because as a student or a person who's sort of in the early stages of blockchain, I think it's really important to know what's possible and a lot of times where you can get that support, either financially or otherwise, for it. So there's different funding routes you can go. This is like Algorand specific, but I would argue and say that this applies for any blockchain that you're looking at that's layer 1. So again, like oh, sorry. So this would go across any sort of layer 1 chain. With funding routes, there are things like grants. So the W3 Foundation, Algorand Foundation, Consensus, which is the Ethereum Foundation, all have grants available. Grants are really interesting because it enables you to kind of create a proof of concept or a minimal viable product, which we refer to as an MVP. And they allow you to get funding for that without having to give away any equity or any shares in your company. So it allows you to really kind of have the financial ability to start developing an idea or a project without having to go to traditional like vending funding or accelerators. The other benefit of this is with Algorand, and I'm sure with the other like W3 and Consensus, we all do things like marketing support. We have technical support available. So people can present something as how do you say, as rough as like a wireframe sketch, or maybe the idea and kind of a rough budget and milestones, and then we can help you build that out, or we can advise kind of people that were available to help build you out. So we have a huge network of dev shops and people that are developers who are happy to sort of work on these new projects and scopes of work. The other thing that we have is developer awards. So the applications for these are specifically for projects that have already been developed. So if you do develop something and you see that there's a utility for that, you can apply for these. Again, I'm speaking specifically about Algorand, but I think and believe that other chains have these as well. It has to demonstrate like a working technology, meaning that it's been deployed on a testnet or mainnet, but it's something that would benefit the larger community, be that users, token holders, or developers within the Algorand ecosystem. We also have things like accelerators, which are meant more for companies in which are seed funding or kind of startups in the traditional sense, that you are doing this full time You might have prior experience in technology, but not necessarily blockchain. And these are sort of the idea of exactly what they say they are. It's like, it's to accelerate the growth of your concept and your idea. So we go in, there's a usually cohort of 10, and we do them from different areas. So we just had one with Asia close. We just did a second one with Europe, where right now we're about to go into the demo pitches that will go out to multiple VC partners. And then finally, we also have one right now in Latin America that's launching. And we're just kind of in the early stages of that, but the cohort has been selected. So we're kind of like lining up all the workshops and doing all these sort of things to kind of get them, again, literally accelerated. And it's the idea that it helps you speed up your project development. It gets your decks and demos in front of some really interesting VCs who understand blockchain and kind of the use case and potential of that. And then if none of that would be interesting, but you're like, how do I get involved in blockchain? I kind of want to start tinkering with this. If I get financial support, that's great. But I don't know where to start. Bounties is a really good place to look. We kind of give out small bounties, everything from like, we need some good Algorand like memes and GIFs, or we want someone to look at this workshop or look at these tutorials and kind of tell us like what could be done better. And then we have very technical bounties that are fixing bugs in our APIs and SDKs, or maybe it's building out an SDK. And so there's this whole like huge range of ways that you could contribute to the community and the developers utilizing the bounties. And so for me, whenever I've gotten involved in a project, I always look at the documentation of the project to kind of see how viable it is. I look at things like the Discord or sort of the forums of the project. And then I start usually playing around with bounties, because you can see right away sort of like what it is the community is thinking about, what it is that we're interested in kind of solving. And if there's things that are missing, a lot of times you can propose those. So it's a really kind of interesting sandbox to get started in. And then again, like from an Algorand perspective, there's a lot of different types of projects that we've supported, and a lot of kind of projects that come out of incubators and hackathons that we've supported. So Algorand Builder is a really large project that has ASA and smart contract integration for frameworks, and it allows you to basically implement those into the back end of your sites. Mentat is really interesting. They're doing large open source SAP connectors and enables API to the Algorand backbone or blockchain. PlanetWatch is doing things like developing sensors to basically measure the air quality from a global scale, and inputting those like large amounts of data and air quality sensors from around the world into a blockchain. It also has like gaming kind of theory reward mechanisms. So depending on how much you contribute, you get these Planet tokens that are written. They're actually Algorand tokens, but with a different name, to people that run the sensors. So that's another way you can get involved, is by looking at sort of projects that have these incentivization mechanisms. Or for me personally, I'm really interested in like social mechanisms or deforestation platforms. We just had another one that we funded that looked at tree deforestation and kind of how you control that or help support this deforestation kind of issues that are happening in places like Rwanda. So we've been working with a Rwanda group that's looking at how you can help the local farmers via blockchain with deforestation. And then we have things like Uncommon Creative, which I like to call the Airbnb for creatives. And it's essentially I believe it's unfortunately Italy, EU specific right now, but it's basically an ability to manage and implement and execute payment for any sort of freelancer-based creative contracts. So as a graphic designer or someone who's worked in freelance, it gives you the protection of ensuring that you get paid for your work. Unfortunately, that's a problem for people that do freelance. And so this was a solution that was proposed a few years ago. And now they're basically building out that ecosystem on Algorand to ensure that anyone who's kind of working in a freelance space or an unprotected space in terms of unions are allowed to find ways to protect payment when it's been executed. So this is my 30-minute spiel. I want to try to do a solid half hour to 45 minutes for questions. This is my contact information. If for any reason you want to reach out to me or ask me questions, laugh, cry, that's the best way to get a hold of me. I wanted to also, so I'm going to start going through the questions in the comments. If there's any additional ones, feel free to add them. So is blockchain really difficult to learn is the first one. Yes and no. It depends on sort of your background, and it depends on what blockchain that you're looking at and what it is you're wanting to learn. For example, for me, I got into blockchain sort of by mistake, I will say, and I found it extremely overwhelming and extremely difficult to learn when I started. But saying that, I want to say that there's a lot of opportunities to learn things in a way that isn't technically complex. You just have to find the people that are willing to explain those. So a lot of things I started looking into was sort of blockchain 101s. There's a website called blockchain.wtf that's really good. I'll put it in the chat. That gives you sort of a really correct, very accurate explanation of everything on a blockchain that you would ever want to know, but from a non-technical, non-mathematical perspective. But if there's specific questions you have in terms of what exactly around blockchain is hard to learn, I'm happy to give you recommendations. For example, for tokens or exchanges, I have a few platforms I really like. For things like building applications, I have some recommendations for that. And then if you're wanting to get into something like an NFT space, I would also recommend that as well. The next question is it possible to develop Facebook-like systems using blockchain? So I would consider Facebook-like systems meaning a social network. And I assume when you say that, you're referring to the social aspects of the network so that there's a conversation-like mechanism. Or say Facebook Messenger. I don't unfortunately use Facebook anymore, but there's a really interesting project. Let me pull it up here so I can get it to you. That's essentially like a Facebook-like social network that is on the blockchain. If I can find it in my history. So let me just pull that up, sorry. So this is a really good list. I actually think it's really comprehensive in terms of decentralized, meaning, so the problem with Facebook, not to get so much into Facebook, is that it's very centralized and it's owned by one core organization, which means that anything that needs to happen or be prevented is decided by that kind of core group of people. The thing with decentralized systems and things like peer-to-peer is it allows you to essentially, sorry, my daughter's in there. It allows you to essentially protect censorship, or for example, in countries where you have highly controlling governments, it allows you to kind of work around those spaces and create kind of modes of freedom of expression, which otherwise wouldn't be possible. So I would look at this itfos.com/mainstream-social-media alternatives. I think that that's a really good comprehensive list for sort of Facebook-like systems that exist on blockchain or in peer-to-peer kind of mechanisms and systems. So what will be the next thing after all the Bitcoins are used? Okay, that's an awesome question. I think what's interesting is with crypto specifically, there's different ways in which the chains have been designed. So things like Algorand, for example, we have an exact amount of coins that we have minted, meaning that there's only a certain amount of coins that can ever go into circulation. With other chains, they build out that minting capacity depending on the demand of the chain. So for Bitcoin, those Bitcoins, basically the way that a Bitcoin can be bought is if someone has sold some, there has to be some available in circulation. So when you go to the markets, or what is this website I go to? I'm forgetting, but I think it's crypto.com is an exchange that I look at quite a lot because they have a really good app. If you're on mobile, it's a really kind of friendly way to start. And I like to call it like the entry point to crypto. I think some of the other ones are much more harder to understand, but they basically will show you a percentage when you look at a coin. It will show you the percentage in circulation, meaning that there might be the certain amount that has been minted. For example, with Algorand, it's 10 billion. So we might have 3 billion in circulation. So we'll give you some percentage of that. It'll say, you know, 30% in circulation. So it'll show you what the total capacity or the supply is for each chain. And those are completely different depending on which chain you're looking at. I don't know or believe that there ever will be like all of the Bitcoins will be used up, because people will always sell them. The higher the price, the more likely is that something called a whale, which is a really large holder of a coin, will sell it. And once that goes back into the market, it's available for people to buy, and typically at a high price, because it's hyped or there's something going on where people are wanting to buy in. And with Bitcoins, you can buy a part of a Bitcoin. So right now, or I haven't checked recently, but last time I checked, I think the price of a Bitcoin was 50,000, for example, USD. So say you don't want to spend 50,000, you can put in $500 and it will give you like 1/10 of a Bitcoin. So you can hold fractional amounts of that coin. So for a lot of people, nobody owns, you know, more than a part of a Bitcoin or a little piece of a Bitcoin because of the prices of them currently. With other chains, you have to buy the whole coin, but the price of the coin is much cheaper. So it will be like 10 cents USD, or it will be $1 USD. So you can buy 100 of them. And then as the price goes up, obviously each coin is worth more. SDK, yeah, software development kit. Thank you for that. Is it possible for mechanical engineering to learn about blockchain who doesn't know anything regarding computer languages? I mean, it depends on what you mean by learn. In my opinion, I think you can learn anything that you want to learn. It comes down to some sort of capacity and availability and maybe patience. I would say as a mechanical engineer, if you can learn mechanical engineering, you can learn blockchain. There's a lot of entry kind of, so let's say hypothetically that you don't know any programming language and you want to learn how to develop a blockchain, or you want to learn how to program and write to a blockchain. Again, using Algorand, because that's what I'm most familiar with right now, is we have an ASA, which is basically the smart contract. Let me see if I can pull this up. So I'm going to post a video, or actually, you know what? I'll post you to the docs. There's a way to create an asset on chain, meaning like if you want to post a contract or something like that, there's a way to do that without needing to know any code, and you can actually just publish the information and upload it on a website like you would a Google Gmail kind of thing. But this is kind of an initial space to look, because there's a lot of code that you can use in a thing called an IDE, which is a developer environment that is based on the web. So you don't have to install a lot of stuff on your computer. You can just open it, and it will allow you to immediately sort of test out code. And the way I started programming myself was not through traditional education, but just through wanting to build my own website. So I started to try to figure out basic HTML. So I would recommend doing the same with blockchain. I would kind of look into what it is you're wanting to build and then like reverse engineer it from there. So if it's that you want to make an ASA, I would look up, or a smart contract, and you want to have that push to chain, I would look at different sites and sort of see what, which of the kind of layer ones, or, you know, is it Polkadot, is it Algorand, is it Kusama, is it Cosmos, Tezos, that appeals to you in terms of the developer documentation, and then just start building it out, and don't be afraid to ask questions, because everyone has kind of started out from the beginning. Some of the blockchains on their Discords have things called stupid question rooms, and I find that sometimes those are the places where the best questions are being answered and asked, because everyone's thinking it, but no one's really wanting to ask it. So I really recommend like just not being afraid to ask questions and trying to get out there as much as possible. The next question is, how much math is needed for I think you mean this. How much math is needed for this something? I'm going to say how much math is needed to do this. At a low, so when you begin, I would say almost none, because any math that you need to have algorithmically or in terms of like cryptographic information is almost always provided by the blockchain. In terms of security, it is always in the blockchain's interest to provide you with that information upfront from a developer or from someone who's looking at it from a management standpoint, because they want to ensure that their blockchain is not going to be hacked or infiltrated in a way that will be detrimental to the chain. So with the majority of chains, again, speaking specifically with Algorand, we have some of the best cryptographers in the world who are Turing Award winners, and they've been in cryptographic kind of research for the last 10 or 15 years, working on the cryptographic mechanisms specifically so that nobody else has to. So for example, for me, I've been in blockchain for a while now, and I've never had to do math that I didn't want to do. And when I have done it, it's because I was just curious about it, and in any way would not consider myself a mathematician or good at it. So next question is, have there been difficulties for you being a woman involved in blockchain? That's another great question. I would say in general, it's very specific to the space in which you're working. For me, the first company, 250-ish men in the company and myself and one other woman who was working in the company, I didn't experience any problems, but I did very much feel that I had to sort of prove myself to everyone to have a lot of what I was doing accepted. At Algorand, I've had a very different experience. It's been a very positive space to work. The head of the head of cryptographic research is a woman. There's a lot of women who are working in both the foundational and the company side who are very active, either directors or at C-level, and they're very eager, myself included, to bring other women into the space. And I think that that's changing more and more as there's more women coming in, that other women see that there's a possibility that they can also participate in this. And outside of that, I have friends who are at Microsoft Research, at MIT, and we are all very interested in bringing more women into the space. So it's something that we're actively working on together, even though we're all in different companies, so to speak, or university research centers. We're all looking at the ways in which we can bring kind of more women and more diversity into the space. Let's see here. Next question. What do you think about basic attention token projects? Will it change digital advertising? I actually don't know if I have an answer to that, because I try really hard to not look at digital advertising. Perhaps Paul or someone who's worked more in VC would have a answer to that, but I kind of in general see that these sort of like new models of how we approach data and data aggregation and sort of dragnet data is quite interesting, because obviously what we've done prior hasn't been working. So when we look at these things again and apply them to sort of blockchain specifically, I think that there's a possibility to completely change the way these centers of or sectors are functioning, and for that matter, like digital advertising is no different. There's been quite a few, I want to say there's been quite a few applications for both the accelerators and our grants that have looked at kind of tokenization and digital advertising specifically for startups. So there's a lot of people that are thinking about that right now. Next question. How much is needed to know for, how much is it's important for computer documents? I'm not sure if I understand that question.
Just skip it for now, Addy. I've asked Kajal to rewrite the question.
Okay, perfect.
We'll do so. Yeah.
So the next question is, how do we develop software using blockchain technology? Are there any open source kits available to develop? So there's a lot of open source technology specifically. I would kind of argue that the majority of current layer ones are open source. I can, again, like post some documentation links to kind of show you like the onboarding, for example. Give me 1 second because I'm bad at typing and talking. So kind of the initial thing you want to do is set up your developer environment, and it looks really overwhelming, I would say, when you look at things like our docs kind of page, but I would encourage you to get familiar with those. Let me post a few so you have kind of a sense of what's possible and what's available in terms of chains. And actually, if there's specific kind of software that you're wanting to develop for blockchain, I would recommend going into the forums specifically of those chains in which you kind of think the documents are what speak best to you, or you're excited about those, or maybe you've heard about those chains, and start asking questions. Let me pull up one more so you have a really kind of diverse sense of what's possible. So those are sort of 3, Algorand, Polkadot, and Ethereum, which you can look at to get started. But it depends a lot on sort of what the use cases that you're wanting to develop out for. So when you say you want to develop software, I guess my question would be, what sort of software are you interested in developing? And then I can give you much more specific feedback for that. Does blockchain contain data? So which kind of data is that, and why is it so expensive? I'm going to assume that that question is geared towards, when you say expensive, you mean expensive to create and mint the tokens. And I'm going to assume that that's related to specifically to Ethereum. So Ethereum is a proof of work chain. It's expensive because it requires each block to be developed or minted using miner technology, and the miner technologies use a large amount of electricity. And as I think I said, I don't know anymore, is that electricity primarily requires fossil fuels. So you're using a large amount of electricity to basically mint these things or push them to the blockchain. And so that's quite expensive. The thing about gas fees, which is what those fees are, that you basically pay as the person that is creating the data to push to the chain, is that they can vary tremendously depending on the current demand of traffic on the network. There's a page, let me see if I can pull it up really quick. I'm not going to let it load because I don't want to crash my Zoom, but you can look at, when we're off this call, you can look at kind of the traffic stats on Ethereum, which is what I think you're what I think you're referring to in your question, Ganesh. So essentially, depending on the time of day that you want to push something to the Ethereum chain, be it a smart contract or a snippet of data or an NFT, which is a type of smart contract for something like art or a house or a transaction that's unique or non-divisible, meaning that you can't divide it, that has to be paid out in gas fees. So the gas fees, again, like I was saying, and I think I stopped my train of thought, was that they can be extremely expensive. I tried to mint something to Ethereum about last week at this time, I think it was, and the gas fee was going to be something outrageous, like it was like 2,000 to 3,000 USD. And then I waited until Monday morning Europe time, and it went down to 60 USD, which in my opinion is actually still quite expensive. For reference, for Algorand to do the exact same thing, one algo, which last time I checked was about 1 USD, one algo you can do 1,000 transactions to. So when you compare, again, there's definitely a benefit to kind of comparing across blockchains what it is you're wanting to achieve. But if you're trying to put large amounts of data onto the chain, like Ethereum is not your friend. And so I would really recommend looking at traffic stats to try to get it at the cheapest times possible. And unfortunately, like with the popularity of Ethereum and NFTs specifically, there's been a huge amount of people trying to push things onto the chain. And so the gas prices have gone up dramatically. What's the next question? So 3 questions, great. Blockchains sound overwhelming for non-technical people. I agree, actually. How do you see creative people over the world accepting and adopting to it? So right now, there's quite a few startups that are happening specifically geared towards creative people or people that aren't interested in programming but want to contribute to a blockchain in a way that is very front end, meaning that they don't need to have any code. They can just push the image or the file up to the chain and then press a button, and it will publish it to the chain and then send them back the verification number to basically prove that that's been put on chain. So for example, for art or music or things like that, you want to sell, assuming that that's what you mean by creative, there's things like Nifty Gateway, Super Rare, Foundation, and OpenSea, which all work specifically with people in creative industries to basically allow non-technical people to accept and work with blockchains in their own sort of creative practices and create ways to sell that doesn't depend on things like a gallery or a record label. OpenSea is really interesting to start looking at because it's available and accessible to everyone. Let me just pull up really quick some information on that so you have it. This GitHub link that I'm just posting also has a lot of information for creatives who are wanting to publish or use blockchain in ways that don't require programming per se. The second question was, you mentioned about creative freelancers using blockchains for payments. Can you explain how that works in a tactical way? So with Uncommon Creative, which is the Algorand startup I think that you're referring to, essentially the mechanism of that is that they have a front-end site, and it allows you to upload what it is your agreement is with the person that has hired you. So say that it's a creative freelancer contract and the person is asking you to make a logo for their company. So the idea with that is that basically the logo will then, you'll make the logo, you'll upload that to the Uncommon Creative site, and they have a person who works essentially in the middle. I think they refer to them as an escrow management person who's holding that money, and will say, okay, the logo is finished, we're approving the money, and they'll send it to you to your wallet, your crypto wallet. So they're managing those transactions, and they're getting the money up front from the person that is basically hiring you to ensure that they first have the money to pay you, secondly, that you're going to get paid, and then they prove that based off of whatever the requirements were for the project, that those had been created successfully by the time that they were agreed to, and that they were delivered in the formats, if applicable, that they need to be delivered by. And so then it's done sort of, like I said, it's like an Airbnb for creatives in the sense that they're basically a platform for goods and services, in the sense that they advertise you or they advertise the work that is available, and then you can follow up, and there's someone in the middle if there's any sort of problems. I don't know if you've ever used Airbnb, but I've used it, and there's been a few situations where there was some issue with the person who had rented my apartment, and so Airbnb was basically the person in the middle who would solve it and ensure that it was solved while holding the person's security deposit. So it's a similar sort of mechanism, but for creative accounts.
Just to add on to that, Adi, I'm sorry, this is very pure. So what would make someone choose a blockchain escrow rather than a regular escrow? Like we have these regular escrow where the bank holds the money till the project is confirmed. Like voices.com, they hold it in an escrow account till the project is completed. So why would someone go to a blockchain escrow in that?
That's a great question. In my opinion, a lot of it has to do with the delays of wires. So specifically when you're working with an international account, for example, when I do work in the US or I do it in the UK or something, there's a 5 day to 7 day delay in payment, and more so if it's coming from somewhere like China into my account. And so with blockchain, it's an instant transaction. It's like it delivers to you within seconds, so that it alleviates that delay of transaction time. You also don't have, unless you're on Ethereum. Again, I have nothing against Ethereum. It's just that the fees are high. If you're not using Ethereum, but something like Algorand or Polkadot or even Bitcoin, you don't pay any transaction fees. So this whole, I don't know how it is in India, but for example, as an American, or if you have an account in the US, you pay like $25. My bank, Chase, charges $25 for domestic wire, $50 USD for international wire, regardless of cost. So if I'm getting a payment for $250 and they take out $50 for the wire incoming, that's a huge incentive for me to switch to blockchain. And so that's sort of the way I would look at it. And if you're working with highly unstable currencies, in some situations, then a blockchain is going to be, or a cryptocurrency is going to be more stable than an unstable currency that's highly fluctuating. So that would be kind of my somewhat quick answer.
Thank you.
Yep. So this other question is, where and how do you use creative technologies with work to overlap with other themes of the exhibit? Oh, we're talking about art. What's the fastest answer I can give you to that? I mean, I think for me, creatively, I use technology as sort of a medium, like someone would use painting. And so I just look at the way I want to explain something, or the way that I see I want to, the way I've conceived the notion of creating something. And sometimes technology is included in that, and sometimes it's not. What is the difference between Bitcoin, blockchain, and Ethereum? Great question. So they're both proof of work chains. Bitcoin doesn't have essentially the gas fees again, or these transaction. I like to call them transaction fees because gas fees I think is a weird name, but they don't have these transaction gas fees that are like highly fluctuating like Ethereum does. But the mechanisms on the backside are rather similar. So there's not a huge difference, other than Bitcoin was sort of created earlier on, and then Ethereum was created in response to that, but that it's also a proof of work chain. So actually, like, if you really want to look at, in my opinion, what is sort of the future of blockchains, you want to look at proof of stake chains. Again, proof of stake would be things like Cosmos, Tezos, Cardano, Algorand, Polkadot, Kusama. Those are all proof of stake chains, and they are more effective because the transaction times are faster, they're less expensive, they're more environmentally friendly in that they don't use as much power, and then they're typically more secure and more decentralized, although that's not always the case. What are the disadvantages of blockchain technology? I would say, in my opinion, and are there any in the real world? I would say they're still quite early in terms of their ability to understand them and use them. They, as all of you have kind of said, and I agree, they're quite complex, but there are people finding solutions to that. I think the other disadvantage is you have to have some baseline computer, I will say, like, comfort of using computers and systems and understanding of technology and internet in general. For people in some countries, the problem of having things like power outages or inconstant means of electricity is kind of a barrier to entry with blockchain. Or if you have a lack of a cell phone, for example, you can't rely on things like the majority of kind of current proof of stake chains is that they're all the ability to execute transactions or do things is also very mobile friendly. So if you don't have a phone or a smartphone, that's kind of a barrier to entry from my perspective. I would also say that there's a huge transition happening right now in a lot of the financial systems. So central banks are just starting to embrace crypto, like MasterCard has recently announced they're going to start supporting crypto so that it will function very much the way like normal fiat currencies like USD or the rupee, for example, would. So I think that we're right at that point of like mass adoption, and it's starting to happen because we're seeing these platforms like PayPal and a lot of things that are very commonly used starting to embrace cryptocurrencies in general as like an exchange of value, which before they were never really taken seriously. So I would say like the disadvantages are starting to be less than the advantages in the sense that people are starting to use them and trust them and adopt them at a really rapid rate. And so I think everyone in this call is like at that opportunity of taking kind of a lead in changing the way that these systems and structures have been built out in the past by finding ways to adapt current use cases or like business models or ideas that you have to how you can apply that to a blockchain. And if you're not sure, there's a bazillion people who are working in blockchain who are super excited to have new people coming in who are like willing to help you bring it onto blockchain and kind of implement it. Why is it important in software technology to use, and how is blockchain used? I think that question is meant to be like, how is blockchain used in,
Let me
I'm still not
try.
sure how.
I've asked Kajal to unmute and maybe
Oh,
ask
okay,
it
super,
directly.
thank you.
I think but maybe I can ask it a little differently, whether it's Kajal's question or not, is outside of financial services, what are the already high use cases appearing? I know clearly in cryptocurrency, et cetera, but what else?
I would say like one of the largest ones right now that is kind of getting mass adoption like at an extremely rapid rate are these NFTs, and everyone is sort of talking a lot about those. So NFTs are non-fungible tokens, but the way that they're being used right now primarily is through art and artists, and allowing artists to essentially show their work to not only an international audience, but it allows them to kind of cut out a dependency to a middleman. And when I say artists, I mean musicians, I mean artists in the traditional sense of creating physical work, and then I mean artists in the sense of creating digital work. It's also being applied to things like trading cards and collectibles. And so this NFT market is extremely, it's just exploding right now. There's the Nifty Gateway market. There's Super Rare and OpenSea are kind of the ones I would look at. Again, I would look at this document that my friends and I wrote, but it covers all the different NFT spaces. And it's very much like thinking about NFTs. I would compare it to something like eBay or Amazon. It's very front end, meaning that you don't have to have any understanding of coding to buy or participate. You can use your credit card to essentially get the ether to buy things, and then you can participate with all these on-chain transactions in a way that's immediate and very fast, and shows you kind of the auction results. And so that's a really interesting thing and use case. There's things like I guess you said not financial. The other thing that's happening quite a lot is sensor technology. So we're looking at things like air quality or water quality. And those things are being monitored and then published on chain. And because that information is available publicly and accessibly pretty much worldwide through these chains, people can then access that information to do like scientific research, or for government agencies to, for example, monitor water quality in multiple places that wouldn't otherwise be possible just using a centralized technology. What is your opinion on world moving toward cryptocurrency through blockchain technology? I mean, I think it's inevitable at this point. There was probably a solid like 6 to 8 years where people thought blockchain was very much this edge case thing, and a lot of people. So my mom is a financial. She was a teacher at a university who taught finance, and before that she worked at a brokerage firm. And so I always kind of used her as like my temperature gauge for how people would respond or kind of thought of crypto. And she always was like, this is crazy, it's never going to work, like how do people invest in this? It's just this like wild, crazy space, and we don't understand kind of what it is, and like we should be investing in stocks. And it's only been in the last year or two where she started kind of taking it seriously. And I think that that's very much kind of the temperature I've gauged for a lot of other people is that it wasn't viable. But now that the amount of transactions that are happening and the amount of really large like multinational corporations and giant banks are starting to think about how to use crypto or use crypto as a kind of asset or a financial transaction mode is very, I don't know. I don't think it's possible at this point for any of that to be ignored, because so many people are now embracing crypto that at some point when the majority of people have moved into a space in which everyone is utilizing it, these people and these companies are starting to look at ways in which they can essentially also onboard themselves onto it. But not only that, but like take advantage of this massive kind of network of cryptocurrencies that people are using to either support sort of the decentralization and the movement towards that, or create more of like a centralized system. Can blockchain be hacked? Yes. there's been some massive hacks previously, like in the early days of blockchain, which I think leads to sort of the distrust at a massive kind of society level, because in the first few years that blockchain was being developed, and I think it was really establishing kind of the baseline of trust across multinational, international spaces, there were a few really large data leaks. There was one called Mt. Gox that I think lost like some insane millions of dollars of currency. And there's been a few, the Polkadot ecosystem had one or two really large leaks where accounts were either hacked or frozen. And so there's definitely those vulnerabilities. One way that people have circumvented that is not relying on storing their information on chain. So the easiest way to explain that is that currently a lot of wallets that exist when you buy cryptocurrency or you're creating it or using it for assets is that you'll store it on an exchange like Binance or crypto.com, or you'll store it in a wallet like MetaMask or something like that. Is to basically buy something. Ledger is one brand, and I know that there's others, but you can buy these. They're called cold storage, which sounds really hacker, but it's actually just like a USB stick that you can take all of your crypto from these exchanges or from an online wallet, and you store it on this drive that then, in theory, prevents you from having any sort of like loss of assets. And so people that have larger amounts of money in crypto or have some sort of valuable assets will oftentimes store these on these cold storage / USB drives to ensure, or external drives or something that's like not online all the time. So sometimes it's even just an iPhone that you would not normally keep online, and you just put it online to get your transactions on and off the network, so that in theory like safeguards you from being hacked, because if these exchanges or the chains are hacked, your tokens or your assets are secured because they're not on the kind of the central or decentralized systems. So I think, okay, so it looks like if there's any more questions, otherwise there's a continuation of the bootcamp using AI to solve business problems, and it says to stay on the link. So if there's any further questions, I'll just stay around for a few more minutes.
Did you see the one from Russ, or did I miss your explanation?
Oh, I'm sorry, I missed that one. If you want to implement a supply chain or a DApp, which would be the easiest or best open source blockchain you should use? I mean, I hate saying this because I work there, but Algorand has actually been, in my experience, the best one. I mean, that was part of the reason why I came to Algorand, was that I was really blown away by the ease and accessibility of creating a DApp on chain in like a few seconds without having to have any programming knowledge. I don't think that there's a best one necessarily, though. Saying that, it depends a lot on what it is that you're wanting to create in that DApp, and it depends a lot on sort of your programming background or lack of background. And I would also say it depends quite a lot on sort of what you plan in terms of maintenance of that, or if it's something you want to sell. So I would kind of ask yourself those sort of questions. I mean, I would look again at the docs for any chain in which you're interested in possibly developing at, and see which one you sort of feel like, okay, I can do this easily. I would look for things like it's called an IDE. So I would look for things called which chains have IDEs, and let me pull up one or two so you have a few examples. But basically what happens is these allow you to not have to set up a developer environment on your computer. Everything is done on the web. The advantage of this is, like, if you're like me and your computer is 5 or 6 years old, it allows you to basically create things using cloud computing instead of your own local computer, and you can do them much faster and much easier, because a lot of the libraries and stuff are even set up for you. So it circumvents any need to like install a lot of things or receive errors on your computer. When I started working at Polkadot and I was interested in developing with Polkadot and Kusama, it took me a few hours to set up my developing environment, where now that they have this online developer environment or internet-based developer environment, it allowed me to like instantaneously start developing something. And so I, again, like would recommend looking at a few different chains and sort of looking at which ones have like very ease of use for your specific kind of ability level and use case. And then if all else fails, like I really recommend looking at the Discords and kind of the community forums. And there's always someone online, regardless of what chain you look at, that's willing to help you. Okay, so I think if there are any more questions, no. So I'll put my email address in the chat in case you missed it during the talk. And if you have any questions or concerns, or something didn't make sense, or you're interested in something I brought up, I'm happy to discuss things further with you. As long as I'm awake, I'm usually online. I'm not always the best at checking my email, but I'm happy to get back to you and support your project or answer any questions in the best capacity I have. Otherwise, I'll hand it over to Paul. I think we wrapped a few minutes early, but feel free to reach out to me, and I look forward to hearing the next session.
Sounds. Oh, are you staying on to listen to the AI speaker?
Yeah.
Okay, good. In that case,
If that's okay. Otherwise,
No. Just so long as he doesn't give you a quiz, right? So
I mean, we can go there.
Awesome. Addie, thanks so much. And some of you may actually, if you pick some of the blockchain business challenges that we have as part of our hackathon, you're likely to interact in some fashion, not only with Addie, but they have teams in China, in Boston, in South Carolina, et cetera, who will hopefully get you smarter. That's part of our whole objective as well, as to get more people to become part of the community. Isn't that right, Addie?
Yep.
Sounds good. Okay,
And,
thanks so much. And I'm going to turn it back to Pradeep, who I think is going to kick off the next session.
Thank you, Ari. Thank you so much. Vamshi, is Sudarshan online?
Yes, sir, he's online. Hemant, can you please make him the co-host? Thanks, Mr. Sudarshan, for joining us a little early.
Hello.
Hi, Sudarshan. Good evening. Pradeep here.
Evening, good morning, based on wherever you are.
Okay, I'm very close to you. I am in Coimbatore, so good evening. Equally, yeah.
Okay, great.
Super. So, Paul, do you want to start off, or do we wait till the right time is there? With assuming that some people may join at 9 for specifically for suggestion session.
That's fine. We'll give them all the keys to the kingdom for the next 6 minutes, and that way they'll know they ought to show up early, right? So with that said, Sudarshan actually works for a company that also has a business challenge in our hackathon. And I think it's okay to go ahead, Pradeep, and start the introduction part. I think people who join at the at the start time won't have lost too much, but that way we can do more Q&A at the end. Right, Sudarshan?
Absolutely.
Awesome. Thanks so much. We just did a session on blockchain, so we're going to continue another, what could be a complicated subject, but I know you're going to make it easy. Addie gave us a lot of great information about blockchain and got people enthused about that. So hopefully you got some big shoes to fill to cover how to use AI to solve business problems. So Pradeep in Coimbatore is going to do an introduction.
Thank you, Paul. Sudarshan, once more, a very warm welcome. This is a gentleman whose blog or personal website reads Nus Radus Pluto. I tried to do a Google search for what it means, and really, Sudarshan, I couldn't find any specific reference to it other than it referencing to the other tagline on your website, which says "Dream of the Impossible." So you actually put me on a scientific research journey because I was connecting it to Pluto, and then so you'll have to sometime today you'll have to tell us what it means. Sudarshan Sandhyapan is an expert in artificial intelligence, data analytics, soft computing, and research and development. Today he is here with us as part of being the facilitator for the AI workshop. He is also the chief scientific officer and co-founder of Buddhi.ai, which is a leading provider of clinical and revenue cycle automation solutions for healthcare specifically. So that's the challenge that they have, Buddhi has put across as well. So those of you who are working on the challenge, maybe it's like coming to the book launch and the author is here. So you can have some good tips from Sudarshan as the day progresses. An incisive leader with over 20 years of experience leading AI research and development projects, from an end-to-end artificial intelligent product system to an AI research and to finalization of product specification. So he has traveled the entire gamut of the life cycle of projects, predominantly in AI and software. He brings on board strong development and technical managerial skills of over 20 years, working with various startups, as well as working with a large and most respected institution, at least in India, as good as IIT Chennai. He brings hands-on Scala and C++ programming experience. He's a veteran. I think for a non-technical person like me, someone who says that he knows C++ himself by itself default becomes a veteran, because it was something that came when I was doing my engineering college almost 3 decades ago. Right now, previously he was also a project officer with the Indian Institute of Technology, and started off his career as a director at R&D at Burning Glass Technologies. He's done his PhD in computer engineering from IIT Madras, as well as his Master of Technology from computer engineering from IIT Madras. But the real icing on the cake for all the students who are on this on this workshop is the last line on his LinkedIn profile, which says, "I am hiring researchers for Buddhi R&D." So all of you eager to get internships, to get jobs in AI, Sudarshan is your man to go. I welcome Sudarshan on behalf of TiE University and all the students who are here. We look forward to having an exciting session with you. The stage is all yours, Sudarshan. Thank you.
Thank you. Thank you. I'm really humbled. Just give me 1 minute. I'm going to start sharing my screen. Right. Okay. Murphy's law is so true, you see. I'm finding it's like some difficulty to share my screen. Just give me 1 more minute. I'm sorry about the inconvenience.
Given that we started early, so you actually have 1 more minute.
There you go. And Pradeep is known to tell many good jokes otherwise, so we're not putting him on the spot at all in that regard. Pradeep, maybe you can speak to, if I'm a student as part of the hackathon, first of all, I have access to all of the boot camps this weekend, next weekend, etc., right?
Right.
And we hope that all the students here will choose to join the hackathon. If you have, hopefully you've picked a business problem to work on. And in that regard, you're working with your local TiE chapter. And we're going to actually make sure your TiE chapter is reaching out to you and vice versa over the next few days to ensure that you can turn out the most innovative and elegant solutions. And so we have speakers like
is there any
Sudarshan
problem,
and
sir?
Addy. Yeah, Sudarshan, are you just, is it a question of share screen or you're not pulling it up? Okay, I think you're coming there.
Okay.
Awesome.
So don't be
So there you go.
surprised.
Pradeep was safe from having to tell jokes. Okay.
Yeah. As the clock strikes 9, all yours, Sudarshan.
Thank you. See, I don't really create slides myself. So I use slides which are available online, and I don't change the names of the authors, and I use them as is, with a little bit of edits if possible. So don't mind if you see some random names on the slides. They are the authors actually. Okay, so I've taken the slideshow from this gentleman, Philip, and so I'm borrowing the slides from his presentation, and I think it makes a lot of sense to follow that instead of redoing it once again. So, okay, so here we are. So our objective is to create machine learning powered applications, or in general AI powered applications to solve problems. So see, there are a lot of things that we need to think before we get into AI powered solution development. For starters, you'll have to ask this fundamental question: is really AI required for solving this problem that you have in hand? Or have you just gotten desperate? See, most of the times, people really get desperate to solve problems using AI so that their solution sounds jazzy or attractive in the eyes of the others. So usually, majority of the situations, you really do not need AI or machine learning or deep learning to solve problems. Most of the times, if you think out of the box, the solution is probably right there, waiting for you to see it. So we typically follow this principle called Occam's razor. This is a very ancient proverb which says you shouldn't complicate the solution unless otherwise it is absolutely required. Right? So you can have a complex solution to a problem only when it is absolutely required. So always aim for developing solutions which are simple so that you can understand it and you can also make others understand it. So that is the bottom line, right? So as a researcher, I have always followed Occam's razor in all my decision making. But let's say in the act of there is no other choice other than adapting AI tools and technologies to solve a problem, sure, go ahead and solve it. And so what we have to do is, so before even you commit to a problem that can be solved using AI, the first thing that we'll have to understand is the length and breadth of the problem, right? So usually in research or usually in applied research, the following steps are something that we always follow. Step one, understand the problem statement. So if you don't understand the question, your solution is always wrong. So spend more time in understanding the question and spend more time in understanding the problem statement, the requirements, and the length and breadth of whatever features that are being asked. And feel free to ask questions. So if the question is framed by a stakeholder, you can or you should ask questions to get the best understanding of the requirements, so that your understanding on the question is absolute. So your solution has a high likelihood of becoming correct. So as I said before, if you don't understand the question, your solution is always wrong, how complex or how intelligent your solution could be. So the first thing is spend more time in understanding the requirements or understanding the problem statements. The second thing that usually we should do is to study if the problem is solved by someone else. So that is what we call literature survey. So when you do literature survey, you tend to find out if the problem that you have in hand is solved by someone else, right? When you find that the exact problem is not solved by any, so the next search process is to figure out a problem which is similar to the problem you have in hand and see if a solution for the similar problem exists. Right? So any input is good input. So the more literature we read, the better we understand the scope of the solution. The first stage is understanding the problem. The second stage is understanding the scope of the solution. Okay, so now when you find out that the solutions which are available out there is not really ready-made and you have to probably develop it better, or you may have to digress it to get to your solution, so great. So that is called the gap study. That is phase 3. So step 1 is understanding the requirements. Step 2, understand what is already that has been done in this particular space. And step 3 is do the gap study. So what is available and what is required to be done? So do the gap study. Step 4 is make an assessment of whether you already have the capability to address the gap. Not necessarily all the time you will have the capability ready-made within you or within your team to solve that particular problem in hand. So you will have to make an assessment of what is the capability which is already there in the team and what is a new capability that might be needed to address this gap. So that is step 4. And step 4.1 is training the team, so that training yourself or training the team so that your capability is sufficiently provided. And step 5, you solve the problem or you start working on the problem. So there are 4 steps before even you start thinking about developing a solution to any problem that involves artificial intelligence. I'm telling you all these because AI experiments are usually very expensive, both in terms of time, money, and resources burnt. And you should always have this idea of fail fast, right? We follow that a lot in our work culture. So whatever experiments that one frames, we should frame it in such a way that you should fail fast. It is okay if you have to wait for 2 years to get success, but you cannot wait for 2 weeks to get into a failure, because that time is totally wasted, right? So we'll have to define a strategy such that whatever experiment that you want to do, break it down into smaller parts so that the experiment validity of the experiment or the design of the experiment is duly vetted within short span of time, so that you can go into the next cycle, make progress. See, waiting for 2 months or waiting for 2 weeks to find that your approach is wrong is a total waste of time. But waiting for a day is okay. Waiting for a few hours is okay. But longer waiting time for failure is very bad. So always define the solution or the process of identifying the solution, or always design your experiment such that you have the opportunity to fail fast. Right? So that is how the experiments have to be designed, right? And so the usual AI exercise itself is very expensive. So in order to minimize the time wasted, we need to do all the homework ahead and then jump into the development part, or getting your hands dirty part. You have to push it to as late as possible. So do the work, prepare the process, or get all the homework done ahead before even you start writing the first line of code. So in today's generation, if you randomly pick 100 resumes from the open world, at least 90 of them mention they know machine learning. I mean, that's what I see when I go for hiring. So when I float a job ad saying I'm hiring for machine learning engineers, you get like hundreds, if not thousands of applicants. And all of them have the mention of the word machine learning, deep learning, and all those jargons in it. But when you ask a question, they're not able to answer. Right? So the mistake that these people do is, if somebody is able to write a piece of code in Python using SQL, and they think they are data scientists, but that's not the reality, right? If you want to become a data scientist, you should have dated the data for several years, right? I use the word dated the data. Yeah, how much time have you spent with data, right? The more the time you spend with the data speaks to you more. It's actually the dating process. That's why I call it date the data. Spend more time with it. Initially, it will fuss a lot. It will test your tolerance. It will test your patience. But the more the time you spend with the data, it becomes amicable. It becomes your pet ultimately. The more the time you spend with the data. So data analyst or data scientist is someone who has dated the data for several years. That's how I see it. But today's generation of students think if they know to write a piece of code using SQL, and they claim themselves as data scientists, which I think, I don't know when people will realize their mistake and start doing course correction. So anyways, going back to the routine. So we'll have to do the planning of how we want to take things forward. And based on that, we have to get into action. So there are 4 types of or 4 levels of AI applications in general. So we call them as descriptive analytics, diagnostic analytics, predictive analytics, and prescriptive analytics. There are 4 levels of analysis that you can do. And the rudimentary way of analysis is descriptive, which basically usually is done using dashboarding solutions and stuff like that. So let's say you have bulk of data and you make an analysis of it and then present the insights from various reports that you can generate from large volumes of data using simple statistics. And dashboarding is a great example of this descriptive analytics. Right. And there is one problem which is given in the hackathon, which is about scraping the internet to find, insights about a particular concept driven by a keyword search. So I saw one problem statement about that, with scraping the web. So the problem statement says you should scrape the web and go collect intelligence from the open internet. Right. And when you scrape the internet, when you scrape the web, you will get tons and tons of information, but you need to put those information to use. And descriptive statistics or descriptive analytics allows you to do that using tools. So that's the fundamental idea. So a lot of business intelligence tools are available, both commercial and open source tools available for crunching large volumes of data to get some slicing and dicing information from it, so that you don't have to really look into all the data points manually. You just can look at various aggregates to get the understanding of what is there in the data set. So level 2 is diagnostics, which goes one step further, which says, okay, if something is there in the data set, let's say an event is present in the data set, diagnostic and analytics allows you to find what caused that event. Right. So let's say if you are collecting data from newspapers and you are tracking, let's say, some sports event, and you're tracking sports event, and let's say if a particular team failed or lost a match, right? So reporting that this team lost the match is descriptive analytics. And if you can find out what might have been the reason for that loss, that goes into diagnostic analytics. So if you can do RCA, which we call root cause analysis, if you can do RCA on the data set, and that falls in the diagnostic analytics category. Usually this particular terminology was called data mining 15-20 years back. The terminology used was data mining. Data mining exactly fits in diagnostic analytics. Right? You mine the data to find out what is inside the data, and can you reason why something has happened or something has not happened, so on and so forth. So the next level of analysis is predictive analytics, where let's say event has occurred and you also know the reason for the event. Can you predict when this event is going to occur next? So that level is predictive analytics. And this is where machine learning comes into play. So when you have the opportunity to predict something which is non-existent, the abracadabra matters, right? You create something which doesn't exist. So you are expecting something to happen based on the patterns of information which has occurred in the past. And you have been tracking the information occurred in the past using descriptive and diagnostic analytics. Now go one step further and try to create an event which is yet to occur. Can you predict that? Or can you anticipate that? So that level of analytics or that level of insight collection is only possible using machine learning. And see, machine learning is not black magic, right? Machine learning uses simple statistics. So in fact, machine learning is a clever combination of applied statistics and optimization theory. Both are mathematical subjects, by the way. Right? Machine learning did not come from the sky, did not fall from the sky. Machine learning has been there for the past several decades. So it became popular only in the last 1 decade, maybe 1.5 decades. But before that, people did not even use the word machine learning often in their resumes or when they talk about stuff. Very, very few people, predominantly from the academic community, spoke about the term machine learning. And by the way, data science is a word which is invented in the last decade. It did not exist before that. Right? They call it information theory. A lot of related words to information theory was present, but data science is a word which it was invented only in the recent times. So data scientist as a profile is invented only in the last decade. There was no data scientist before 10 years, right? So I get furious when somebody calls me data scientist, because we were doing research even before the word data scientist itself was created. Right? So using tools which are available out there, today machine learning is a commodity. I mean, Microsoft allows you to do machine learning without understanding machine learning. Amazon allows you to do, Google allows you to do, IBM allows you to do. So a lot of large giants have opened up platforms, and they have commoditized machine learning. So anyone who has the interest to play with it, right, who has the patience and perseverance to play with it, can go and make wonders using these ready-made solutions. So that is level 3. And level 4 is the premium, which is prescriptive analytics. So let's say you have predicted that some event is going to occur. What can I do to circumvent that? How can I take corrective actions around that? Or what is the corrective action? So that is what is covered in prescriptive analytics. And this is where, knowledge comes into play. Real intelligence, real human intelligence, or intelligence as a word, comes into play in level 4. Up till level 3, there is no intelligence. It is only mathematics. So level 4 is real intelligence. And this is where intelligence is used, and used in terms of ontologies, knowledge bases. So these are, terminologies, or these are technologies used to mimic human intelligence and human decision-making potential. And it represents it in a form so that computers can also mimic that, right? So ontologies are the ones which allow a machine to smartly take decisions based on given situation, based on the given environmental conditions. So that is level 4. So all these 4 levels of so-called AI applications are possible. So you need to figure out which level your problem is going to fit in. So I have collected some of the problems from the hackathon. There are a couple of problems about chatbots. There is one problem which tries to match between companies who have capabilities against government contracts. I mean, they make offers, or they invite contractors to take up job. And one company has put that problem statement in a hackathon, where you'll have to see how a particular company can fit a particular contractual requirement or a particular contract, right? So I have worked in a similar problem in the past, where we used to match resumes and jobs, right? So there is a job posting from an employer, and there is a resume which represents a particular candidate, and we go and match the resume and posting. So I saw a very similar problem floated in hackathon, but in a different application perspective. But the core logic of matching is the same, is exactly the same. So that is another AI powered problem I saw in the hackathon. And the next one, which was interesting, which said if you have a YouTube track, and if the YouTube track shows a timeline during the start of the video, let's say if the video is 2 hours, and usually they put an index, at least some of the YouTubers put an index in the front saying, okay, go to this time to see this topic. So if there are multiple topics in a long video, they put a table of contents in the beginning. And this hackathon problem statement says, if the video contains such a table of content, go figure it out and extract that. So that is what has been coined as a problem. And this problem can be solved pretty straightforward using OCR technology, or using, I think OCR is more than sufficient. Using OCR technology, if you can find out, and if you can cleverly apply some heuristics to see that, okay, whatever text I'm seeing appears like a table of content, so let me extract the table of content contextually so that I can finish off with my solution. So that is another AI problem I looked at. And there was one more problem, I think. Just give me 1 minute. I have... Yeah, there is one problem related to scraping. So it says do an automatic market research for a set of given keywords by mining the internet. So this is another problem which involves web scraping and doing a lot of large scale data analytics on top of it, on the scrape data to get the solution done. And there was another peculiar problem which says, given a mark sheet of a candidate, can you extract the information from that? So this is also another AI problem. I mean, you can call that as a machine learning solvable problem. And I'm going to talk about all of this in some time now. So I'm just going to give you some cues on how to go about solving such problems, because many of these problems are solvable using ready-made tools. There are some ready-made tools. If you can tweak it, it can greatly help you solve such problems. And the other problem that we have floated ourselves is to build a question answer system on publicly available ontologies. So I won't call it as an AI powered thingy, but I would probably call it as a natural language understanding problem. So I won't call it a machine learning problem, because if you use simple natural language understanding toolkits, I think most of it can be most of the questions can be answered for the problem that that buddy.ai has given in the hackathon. Moving on. So when we look at a product, an AI product, so if you look at this Venn diagram, so it's actually a combination of multiple aspects of it, right? So we have the business objective, which is the problem statement given to you, and you have to look at it from the user's perspective, the ones who are going to consume it. Again, that mention is also there in the problem statement. And the third important thing is the choice of technology which you're going to use to solve the problem. And most of the hackathon problem statements contain a potential list of possible technologies that you can try. So that is also known to you. And the last one, which is the data science and modeling, this is the unknown piece for all the given problems. And this is what we expect you to explore and come up with some interesting combinations. So the first three circles, you have all the data from the hackathon problem statement itself. And the fourth one is your choice. So you have to play with whatever is out there and try to make the best choice suited to solve the given problem, right? And so I'm going to skip it. So these are some of the things that we need to take into account when we are working with AI in general, right? So I'm just going to read all these questions, and these are some of the questions cannot be answered in one lecture, but these are questions you need to keep in your mind so that you find out the answer at some point in time in the future, at least. So let me take the first question. Will this actually add any value? So whatever solution that I'm going to build, is this going to add any value? Right? So the problems given in hackathon are supposed to add some value. Otherwise, these employers or these companies would have never floated these problem statements to you. So this question is a no-brainer with respect to hackathon. But in general, if you take an AI problem and if you try to attempt solving this problem using AI solutions, ask yourself, what is the value addition that you're going to make by using artificial intelligence or machine learning technologies to solve the problem? Can you get similar value by using other technologies? So you need to do this comparison all the time and go into this hard route, which is the machine learning route, only when it is absolutely required, right? Because if you have to get into machine learning, it will force you to learn a lot of things. Your learning curve will be very steep. If you are the steep learning curve person, great, congratulations, welcome to the group. But if you are not a steep learning curve person, then I would take a step back and validate your decision of doing it in the AI style, right? So that you can equip yourself more and then probably attempt the next problem with a better approach or whatever. So that is something we need to always ask this question. And the second thing is, what is the problem that we are trying to solve? And is AI ML well suited to address this problem? So let's say if you get a bad result, how do you mitigate that? How do you defend it? So in my experience of building several AI products, I have had nightmares answering questions from the clients. If the let's say if the AI engine makes a prediction, and if the prediction is a subjective prediction, and it's impossible to convince somebody when you work on subjective problems. Let's say I have a flower, and let's say I have a robot which is going and checking out this flower and says this flower is beautiful, right? And as a human being, I go check out that flower. I don't like that flower. I say it's ugly, right? Who's right? Nobody can answer, because the beauty of the flower is subjective, right? So for the robot, with whatever parameters the robot is configured, it appears to be good. And with whatever parameters I'm looking at the flower, it looks bad. So how do you handle that? So usually when you build AI solutions, try to stick to objectivity. I mean, avoid subjectivity till you have the last drop of blood in your body. Avoid that, because if you get into subjectivity madness, there is no comeback, right? Trust me, I've burned my fingers multiple times in my early experience. So nowadays, I don't do anything which involves subjective decision making, because it's very, very hard to convince a variety of customers. Some customers may like it, some customers may shout at it. It's very hard to convince everybody. And as a product company, you have to ensure your product sells across the board. So if you build products which are subjective in nature, it's going to be a really hard time for the support guys to answer questions from the customers. So when you get a bad result, can you defend it? This is something you need to be very, very cognizant about, because this is where many AI companies burn their fingers. I mean, they are not able to reason why they got a bad answer. Because you cannot say that my models are bad. You can never say that. So you will have to always come up with some workarounds to give a convincing answer to the user, and eventually it becomes harder. And so other question that we need to also pay attention to is the ethics and privacy matters. So nowadays, privacy has become a point of concern everywhere. So in fact, new AI paradigms are being invented. For example, there is this process called federated learning. So it is don't think it is another form of machine learning. It has nothing to do with machine learning. Federated learning is a paradigm where you build models local to data residing in different perimeter networks, and then you only get the models out of these networks and try to consolidate the models into one larger model and depute the larger model back to the client. So the places where you cannot share data, when the client is not willing to share the data, so you send your modeling engine to the client site and build models there. And when you build models there, the models are your property. The client cannot own that model. Data is theirs, but model is yours. So you can always take that model out. So when you get the models out from different such vendors, you can try to consolidate those models and try to do transfer learning amongst them. So, and federated learning is a framework which allows you to do that seamlessly. And especially in healthcare, when none of the hospitals will share the data to a third party, so you don't have any choice other than running your application in the hospital's network. You don't have any other choice. So in such situations, federated learning is the only way to go. So with more and more of such problems, new frameworks get developed. So that is actually good news. But when you design something, always keep privacy as a matter of importance. And of course, you should also design things which are fair. So fairness in AI is another area of research in modern times, because AI can be meddled to do whatever in an adversarial style. It's possible because it's an idiot box, like we used to call a computer several decades back. So AI is also very, very gullible, right? It is only learning what you give it for learning. So if you can make AI work in the opposite direction. So as a researcher, you have to promise to yourself that you will never put your skills or your capabilities towards bad applications or abuse of AI. You should take an oath saying you will never use your capabilities or skills which will promote abuse of AI. So that is something we need to do it. The law does not protect anything. I mean, the law does not control you today, but this is the individual responsibility, if you want to call it that way. So I'm going to switch my presentation now. So I'm going to move on to another one. So there are two slides that I've gotten. One is about a chatbot, because there are two problems which talked about chatbot. There are two questions or two hackathon problem statements on chatbot. So just want to give you an outline of a chatbot. And then there is one problem which talked about scraping the web. So I'm going to also talk about how do you scrape the web, and what are the tools with which you can scrape the web. And these two slides I have. So I'm going to share the chatbot slide.
Till Sudarshan.
Yep. Yeah, shoot your questions. Feel free to ask.
I was telling that till you pull up your slides, people can start posting their questions. And since Sudarshan has been kind enough to go through all the challenges, maybe if you have some specific questions relating to the challenges you're working on, I'm sure Sudarshan will be able to give an insight from the AI perspective for that as well.
Sure. I mean, I'll pause. I mean, I'll wait for questions if you have some.
No, they can put it on the chat and then we can take it after you finish your presentation.
Okay. Okay, likewise, this slideshow is also borrowed from the internet. So I'm going to use the slides. Why do we have to build a chatbot? I mean, there are two problem statements in the hackathon, so which actually motivates us to see how to build chatbots. But why do we need that? So interestingly, this is the next in our paradigm shift. So look at this flow chart. So initially we were typing. I mean, I'm sure most of the audience here might not be born when we used to type on the keyboards. And then there came the mouse, or there came the graphical user interface. I think during the 90s, I have worked with text-only machines like Unix boxes and DOS boxes and novel netware boxes, where we get only black and white screen, and we do programming in those machines. It's only typing, nothing else, right? Text screen, no graphical window. And then came Windows 3 something. I think I used 3.11 some time back. So there we can click on something, see something on the screen. So we are talking about how the machine and human interact or interacted in the past. Then came touch. So we used a mouse to touch some part of the screen. Then came touch screens, where I can use my finger to touch a part of the screen. Then came gestures with cams in front of the computers, cams in front of the mobile phones. You can make gestures, and the machine is able to understand what gesture you make, and based on that, the machine is able to do some activity. And then came voice commands. So voice commands is a nice transition. So during my master's program, the late 90s, speech to text was an unsolved problem. Back then, I'm talking about 23 years back. So that time, speech technology is the research area, is the hottest research area during that time. And people were using hidden Markov's model, the traditional Markov chain models, to solve this problem. And the speech to text was probably 60%, 70%, and not much progress was made during the late 90s and early 2000s, right? But everything changed when NVIDIA came up with GPUs. everything changed. And I think it is a radical shift that happened before GPUs and after GPUs. So when GPUs were made available by NVIDIA for general purpose computation, whatever was dead, I'm referring to neural networks. Neural networks were dead during the 80s. 90s, nobody, I don't remember anyone working on neural nets during the 90s, or very few people might have been working, but it was killed because of dearth of computational power. So neural networks are very capable of solving larger problems, but we did not have the computational capability to solve problems using neural networks. So people buried it. They said, okay, this is not practical. I mean, you cannot go after neural nets to solve problems. But once GPUs were out and things started flashing, right? People revived whatever was buried under 200 feet, and they revived everything, started playing with them. Because neural nets, the mathematics involved in neural net is very funny because it's 100% parallelizable. Right? We only do matrix multiplications, and everything you do is data parallel. And neural networks, it's like, it's a problem created for parallel computing. And people realized that, neural nets require parallel computing, GPUs provide parallel computing, let us marry these. And people married it. And there you go. Whatever was not working in the ancient past started to work. RNN is one such thing. So the recurrence neural network as a technology was invented probably in the 60s or 70s. Neural network, the recurrent neural network. In short, they call it RNN, which is a sequence processing neural network. It can handle a sequence of something. And speech is a sequence. It's a sequence of phonemes, sounds. It's a sequence of sounds. And hidden Markov's model is also a sequence processor, but it's probably not a very efficient way of processing it. Whereas RNNs opened up the Pandora box, and it opened up a lot of opportunities. And whatever was not solvable yesterday suddenly became solved problem. Today, you don't see anybody working in speech technology. You seldom see somebody working in speech technology. Probably they work in a language for which there was no models or whatever. And now speech technology is seen as a commodity. So you can buy that API for a few cents, and you can speak to the engine which is configured for the API, and the recovery of the text is at least 98-99% if you speak in English. If you speak in English, it's perfect. It is so perfect. I would say 99% perfect. And probably American English and European English, it is top notch. Indian English is still challenging because Indian English has probably 100 different varieties. Different parts of the country speak differently. So it's still a challenge. Maybe Indian English is 70 to 80%, but the Western English is solved, is practically solved. So whatever problem that was unsolved 20 years back, or let's say 10 years back, just after GPUs were invented, the problem magically got solved just by mere application. People applied a standard technique on the speech recognition problem using GPUs, nothing, with no tuning. The out-of-the-box solution itself was 95% plus. It was like magic. Honestly, I would say, I don't believe in calling AI as black magic, but deep learning is still an alchemy. It gives you an experience like alchemy. It is really like black magic. And the guy or the person who builds a network himself or herself cannot understand why it is working or why it is not working, but it works, man. That is the power of deep neural networks. And when you configure it appropriately, it works like a charm. So that changed the sequence. So voice commands became so simple. So there used to be times when people give voice commands like open, stop, close, one word, right, using HMMs, because HMMs were good in identifying words. But if you speak to HMMs, it won't identify. But today you can sing a song and probably the AI agent sitting listening to you will sing back. That is the level of speech recognition we are living in. That is the level of speech recognition we have in this time. That's amazing. That's an amazing technology. But I'm also scared. Why? I will never have a Google Assistant or any Alexa kind of a device in my home, because I'm always conscious that these guys are watching or these guys are listening to me all the time, 24/7. So it's probably I come from a different generation, but for you, it's very cool to have an AI agent speaking to you as if a human being is speaking to you, right? So now, once you start speaking to it, right, you expect dialogue. You expect dialogues, right? So there used to be a time when we give a command and the machine reacts to the command and does something. When I say open, it opens, let's say, the refrigerator. When I say close, it closes the refrigerator. When I say turn on, it turns on the music system. So such commands were there even before 2 decades, because HMMs are good in identifying words. But today you can speak to it. Hey Alexa, can you play a song for a sad mood? Alexa, play sad songs for fitting your mood. It's happening today. And you can speak to your phone, and you can speak to Google Assistant or Siri, and you can have a dialogue with them. And they cleverly give you some very interesting responses. I mean, I would say clever, but not human yet. They are clever AI agents which can talk to you back. So chatbots will become a normal thing in the future. That's what I'm thinking. You will not know whether you are speaking to a human being or to a bot. Even today, we don't know that. We don't know that most of the times. When you speak to a bank teller over the phone, not teller, a bank agent over the phone, you don't know whether you are speaking to a human being or a machine, because the voice rendering is so natural, and the spoken language is so natural. It's very hard to differentiate whether you speak to a human being or whether you speak to a machine. So today, if you have to run Turing test, all Turing tests will fail. Humans will fail. That's why people no longer use Turing test, because Turing test is no longer the right test to check the intelligence of an AI agent. That level is gone, already gone. We have gone past that level already. Anyways, moving on. So the next level of transitioning is having a natural conversation, and then finally the concept of think. Can AI think? It is already trying to do a lot of thinking job today, but that's not in the scope of the hackathon problem statements that are being floated. But the next level of chatbots would be somebody who can put the mind in finding an answer, and these chatbots will remember the last conversation. So it is as if you talk to a human being, and the human being remembers the last conversation. The human being remembers the profile of yourself, so that the next time when you start a conversation, it won't be a fresh conversation. It would rather be a continuity of whatever you or wherever you left before, also along with the world knowledge. See, that would be scary and awesome at the same time. Okay, so how do we build a chatbot, right? How do we build a chatbot? So there are a lot of ready-made solutions available. So this slide, the first level of building a chatbot is you can have some templates. And this is older technology. Today it's much better than that. You can have templates, and you just try to fill in those templates. What is your name? I am Eliza. It's a very easy dialogue. So what is your name? What is your name is a standard question, and you can figure out from the question name is being asked, and the chatbot can be configured to give a response, because name, what is the name? It's a standard answer. So you give the answer in a template. So I am Eliza. I'm using the word Elisa because Elisa is one of the oldest chatbots I have worked with. It's probably created in the 70s, but I played with them in the 90s. And it is a simple C program. And it is powered by a rule engine. And the rule engine is a text file. You can actually go and read the text file. Just try to, it should be available online. Try to play with Eliza, Eliza. And it's a very cleverly written program. And I have tried speaking to Elisa, and I've spent probably 10-15 minutes talking to that bot. Right? And all the answers that Elisa can give are reasonable and very convincing. When I tested it during the 90s, I mean, today it won't convince me, but back in that time, it was very convincing. So I could clearly remember my experience with having a chat with a bot, knowing that it is a bot, right? And the way it was implemented is plain templates. In fact, both of the problems that have been floated here can be solved using templates, because the first one was HR information systems. So how many ELs do I have? How many earned leaves do I have? Is a question an employee can ask a HR, right? The same question can be asked to a bot. And if the bot knows which employee is talking to the bot and the outstanding ELs, the bot can answer. Giving a templated answer is sufficient. So it is not a bad idea to implement the chatbot using rules. So it need not be really AI powered. You don't have to use natural language understanding, natural language generation, all these advanced topics, unless otherwise it is required. So find out what are the possible questions that one can answer just by cataloging it. You just catalog all the possible questions and try to provide a templated answer, which is more than sufficient for an employee, because the employee is not going to engage with the HRIS bot for more time. So all I will ask is, how many ELs do I have? How many casual leaves do I have? Or when is my appraisal due? Or can I take my vacation this month? So these are some of the standard questions people ask regarding leaves, because leaves was the use case given in that hackathon. So I'm using the same concept here, but there could be other questions asked to a HR. But in my opinion, the questions are finite. So if the questions are finite and the answers can be templatized, I would suggest it is better done the rule style. It need not be NLU style, because NLU will be overcomplicated. But you can also combine the rule style and NLU style and come up with a hybrid approach. That should also be possible. That would be awesome, because you get the best of both worlds. You can quickly prototype something using AI, because chatbot is a ready-made API in Microsoft. It is also a ready-made API in Amazon. I think it is also a ready-made API in Google. So you can consume those APIs and build an out-of-the-box solution, the baseline solution, and then enhance the application of that solution for the required domain by providing templatized answers and templatized questions. So you can also train the bots. That's what they say. You can train the bots with different questions, and the bots will learn based on the questions and answers. But that could be a costly affair, because it might be expensive for you to create the training set, expensive in terms of time, and effort. But if you catalog the questions, and if you try to find that the answers to those questions can be templatized, you can solve it using rules. So that is one option you should always consider if the question set is finite or it is near finite, right? So always think about that. So the other chatbot is also about recruitment. So it's more like, I understood it as applicant tracking system. So let's say if I had applied for a job, and can I find the status of my application, or can I do an inquiry at an employee site about a job opening, right? So something related to recruitment. That's what I understood it, but it could be bigger than that also, because I don't see chatbots fit anywhere else. I don't see that fitting anywhere else. See, either you should be a job seeker talking to an agent, talking to the recruiter of the employer and asking doubts about this position and whatnot. and or it could be a job seeker talking to the recruiter about the status of the application and what is going on. Again, in this situation, the list of questions is finite, as far as I understand, right? So I would suggest that it would be ideal if you use a standard bot platform, and over and above that, if you use some templatized questions and answers, and that should probably serve the purpose. That's what I think, but you can play with the available solutions. So I'm going to directly jump to the place where I have listed some of, or not me, the slides owner has listed some of the libraries. So this is another, this is something which you can see. So some places where different chatbots are already deployed, right? So the slide might give you some insight on how chatbots are already playing a big role in some interesting places. And chatbots can also misbehave. So remember that always. That's why I said always have fairness, ethics, and morale when you design something which is pseudo intelligent, right? So when we design something, when we give the power of intelligence to a machine, if the machine does anything wrong, it will be pinned on you. I'm not saying it by law, at least by moral responsibilities, it will be pinned on the creator. So be cognizant about that, and always ensure that the intelligence that you create is used for fairness or used fairly. Please keep that as a request, my humble request. And so I'm going to skip to the slide which contains. Oh, this is another note we need to think about. So see, if you have the chatbot along with the synthesizers, right, the voice synthesizers, and this is a side effect of it, you can make any character speak. So there is, I'm sure you would have heard about this. There's something called deep fake, DEEPFAKE, right? Deep fake is a technology with which you can make anyone speak anything. You just go and search for deep fake videos in YouTube or in the internet. If you search for it, you will see weird interviews by people who have never said so. But those videos are created artificially by using deep learning tech and also voice synthesizers, and of course natural language processing also. So in my opinion, it is an abuse of AI, but it is also another use case which can also have good use cases, but deepfake is a very bad use case. I don't know, just have a look at it. These are some areas which are kind of open-ended. Right now there is we don't have any control over these kind of applications, and there is also the research community is already asking for a consortium which will regulate usage of AI. People are asking for, we need to have a governing body which says what is right and what is wrong when you build AI solutions. Right now there is nothing. So it is only based on the laws of the land, and we don't have any separate laws about AI or AI applications or AI agents or robots. Robots are still seen as machines. They are not seen as machines which can take decisions on their own. But those are like problem areas, and people are working on it to solve, but it is still work in progress. Okay, some of the chatbot builders. These are some of the chatbot builders. I suggest you use Microsoft bot framework, which is very easy to use, and you should try playing with that. So just make a note of it, and these are some of the platforms which you can use ready-made to build your chatbot. And these are like the messaging services which are available, so you can actually learn to train. I mean, you can train your chatbots using extracts from these services. So why I'm saying this is, let's say if somebody is having a conversation in Facebook over a particular post, or let's say if somebody is having a conversation over a Twitter post or whatever. So every reply is adding to a dialogue. So if you can scrape that information, you don't have to scrape, you can actually download it. I mean, you can get the dumps of your data. I think in Facebook, you can download all the dialogues or all the conversation that has happened in your page. That's definitely downloadable. Likewise, Twitter also allows you to download. And Twitter also provides APIs to download publicly available data. So you can download those conversation and use that conversation to train your bot, right? So you don't have to create, I mean, you don't have to create those data sets from scratch, because it's very, very laborious and time consuming to do so. So existing dialogue systems can be leveraged to create the training documents, which can be which can be used to train the chatbots for a particular domain, if you can filter it that way. And we already have these voice recognition APIs. That's what I said. Right now, we live in a world where voice recognition or speech recognition is a commodity. And this commodity works like a charm. It works like a charm. So you should leverage it. And chatbot with voice, right? Chatbot with voice gets you an AI agent, an interactive voice response agent. You cannot call it IVR, but it is a bot which can speak to you in your native tongue most of the times, right? And you should explore that. And these are synthesis engines and a lot of guides. I'll share these slides with the group, so you can always take it from there. And so I'm going to quickly show a demonstration of IBM's chatbot, which they have created. And let's see if I can share that part. Just give me 1 minute. So if you have any questions, you can shoot it. I will try to answer them as I prepare the demonstration. There you go. So I just clicked on one of the links in that page and I landed it here. So this is a chatbot from IBM, and it can answer some fundamental questions. So it has 3 use cases. One is making a payment. The second one is booking an appointment. And there is also recommend a credit card. This is a bank bot. It's a demo application. It's not very smart, but you can actually have a dialogue with this particular bot. So I'm just going to play with it. Just see. So it says it's an use case. Okay, it's a use case, and it says if I am a customer and if I have a credit card that I have to pay the dues. And that is where we are starting this conversation. So it is asking for which card I should pick. I'm just going to pick one card randomly. And it will tell me what is the outstanding in that and what is the due. And it says there is a due and which is payable by March 6th, 1 more month to go. And I can choose to pay it today or pay it by due date. So when would you like to pay? I can click on it and I can also type. I say tomorrow. Right? So it correctly found out that tomorrow is March 1st. There's nothing AI here. It is just simple logic. Today is 28th February and tomorrow is March 1st. There's nothing no black magic here. and your minimum payment is $50 and balance is $430. And how much do you want to pay? So I am going to say I will pay half of it. Let's see what if the bot can understand it. Okay, did not understand it. So let me say I'm going to pay 400. Okay, so again, there is nothing hyphenda here. It is just reading this sentence and converting that to a number and says, okay, if you make the payment of 400, so it is confirming if the payment is correctly read. I'm going to say yes, it is correct. So that's about it. It's a very simple bot, nothing fancy in this, and no thinking, no decision making. It's a simple bot. And if you can you implement it using rules? Probably easy. It can be easily implemented with rules, but this bot uses IBM Watson's chat engine to solve this problem. But you can also try similar chatbot engines which can have a dialogue using fundamental constructs. And if you want to make them answer better, then you'll have to supply additional information to those bots and make it workable for whatever problem statement you have in your hand. So that's about it. So I'm going to stop sharing here. And Microsoft's chatbot technology is kind of very good, and you can play with it. And so I will share the slideshow, and there is a link which will take you to Microsoft site, which will also give you a how-to. It's a tutorial kind of a page, which will tell you how to use Microsoft's chatbot technology to build your bot from scratch. So that will be available. So I'm going to pause here, and if you have any questions, I'll be glad to answer. Okay, so let's move on to some of the web scraping basics. So there are, okay. Hey, am I audible to all of you? Someone has said I'm not audible. Yeah, okay, thank you. Okay, so there is one question which says, which kind of mathematics needed for ML and AI? Okay, so there is no kind here. So I would say, for starters, if you have some understanding of linear algebra and probability and statistics, that should be good enough to get into the groove. So the higher level mathematics and all will be required when you create new algorithms yourself, right? For understanding the existing machine learning algorithms, if you have some understanding on linear algebra and probability and statistics, that should be more than enough. And yeah, that's about it. I think if you understand linear algebra, something like differentiation, vector calculus, and integration we seldom use in machine learning, but differentiation, especially the first derivative, we use a lot. So we need to be comfortable with that. And matrix algebra, I mean, how do you add matrices? How do you multiply matrices? What is a rank of a matrix? What is an inverse of a matrix? And if you are comfortable with such things, then you can have a ball. You have nothing to fear. But if you want to understand higher end algorithms, let's say algorithms like support vector machines, algorithms like pack guarantees, and those kind of stuff require a little bit of higher mathematics. But for building a support vector machine, you don't really have to understand the math of support vector machine. As long as you get the intuition correct, as long as you have the intuition of support vector machines, that is good enough. You don't have to understand the KKT conditions and the higher order math and all. You don't have to understand. But if you are a deep learning person, and the amount of mathematics you require is very less, because most of the deep learning tech uses only matrix algebra and first order derivatives. That is all it does. So if you are comfortable with first order derivatives, especially first order derivatives of exponent function, which is the same, right? Differential of e power x is e power x only. And if you can understand the basic differentiation of polynomials and exponents, and you will be very comfortable. And matrix algebra is all you need. And for starters, even the highest level of neural nets does not require complex mathematics. It only requires matrix algebra and differential calculus. That is all it needs. So if you look at deep learning tech, let's say if you look at convolution neural networks, or let's say if you are using transformer based networks or LSTM based networks, the networks may look really big, but the fundamental equations are following the same structure, right? So if you have the patience to see that structure, then you will see that the same structure is getting repeated everywhere. So the structure will just have differential calculus and matrix algebra. That is all it will have. And just refresh your 11th standard or refresh your higher secondary mathematics. That is super enough to get into deep learning tech. That is what I see. But in the general machine learning community, you will probably need more if you are going to take machine learning as a profession. If you are taking research as a profession, then you need to take mathematics very seriously. But if you are just a business user, or if you are just a casual user, or if you are an applied researcher, linear algebra, probability statistics, and differential calculus. Let me simplify it. Matrix algebra, differential calculus, probability, and statistics. That is all you need. And you will still be a king in your space. Okay. And one more question, hardware requirements as a student who's a beginner in ML and AI. You can use your laptop. What else you need? You don't need anything fancy. See, the thing is, if you are needing GPU kind of hardware resources, you get a lot of free credits online. See, Microsoft gives you free credit. Google gives you free credit. Amazon, not sure. I'm not sure. But definitely Google and Microsoft are giving free credits. And if you plan your experiments appropriately, and those free credits are more than sufficient to run high compute experiments, they give you good credits. They give like $200, $300, which you can keep for some time. If you use it cleverly, I mean, you have to plan. If you plan it, and that $300 credit is more than sufficient for your practice problems. And when you get acquainted with the technology, then and if you are in need of a GPU, then you need to spend a few tens of thousands Indian rupees, or let's say about $1,000 or $1,000 to $1,500 on GPU itself. I mean, you may have to spend that, but I would say it will live for at least a couple of years, that investment. And after a couple of years, the GPU will become old, or it is no longer powerful to solve your problems, then you may have to reinvest again. So I would suggest to avoid investing a lot in GPUs, because the lifetime of a GPU is less than a year. I mean, not in terms of functionality, in terms of speed, right? In terms of relevance, it's probably a year. So I would suggest you try to use some community resources or academic institution resources or resources which are available online for free. Those kind of things I would suggest you use. Okay, so how can I get hired in your company, researcher? Please reach out to me after the meeting. I will talk to you about that. Sure. Okay, moving on. So I'm going to spend some time on web scraping basics, and let's see how this goes. So so why do we have to scrape the web? So the first reason is web has very rich information, but unstructured information. We get a lot of data from it, but you don't get insights from it unless you read, understand, and connect the dots. You don't get anything from it. It is a lot of information with no connection. So if you put those data to use by connecting them appropriately, then it is an oracle. So that's why we have this new deep learning tech called GPT-3. So the third version of general purpose transformers, which was launched very recently. Not launched, I would say it was publicized very recently. But the access to it is still by invitation. I'm still in the queue. I've not got the access yet. There are a lot of people like me in the queue. So GPT-3 practically indexed the internet. So it practically indexed the internet. So if GPT-3 is used to build a chatbot, for example, this chatbot can practically answer any questions that you might ask, for which the solution is there in internet, of course. That is the contingency. So if the answer to the question is available in the internet, then this chatbot, which is powered by GPT-3 model, can answer it in a jiffy, because GPT-3 practically indexed the internet. It is like Google indexing the internet, right? And GPT-3 is also powered by them. Google is one of the contributors of GPT-3. There are other contributors also. And whatever index they have used for building this model. And this model practically memorized the internet. And this model is so huge, it has hundreds of billion parameters. So generally in deep learning world, or in the neural network world, we use a thumb rule. It says if you have 10 parameters, then you need at least 100 samples to train that network. That thumb rule is no longer true, but that is a thumb rule we used to follow when we build smaller networks. But if you have to follow such a convention, and let's say if this network had 200 billion parameters, then it should have at least used 2 trillion input training documents. 2 trillion. I don't know whether they indexed a trillion documents. I'm sure they indexed several hundreds of millions of pages, maybe billion pages, I'm sure, because there could be a billion pages, several billion pages in the internet, which is indexed by Google. And I'm sure all those indexed pages are all used for training this GPT model. And this GPT model is a natural language model, right? It basically understands the sentences which are there, or the paragraphs which are there in the document, and it understands the language by going through tons and tons of text. That's what it does. So GPT itself is not a product. You cannot sell GPT-3. It is an underlying platform on which you can build a lot of applications. And chatbot is one well-suited application which can be built on top of GPT-3. Of course, you can build chatbots on GPT-2. GPT-2 is in public domain. You can use those models for building chatbot, but that itself would be very, very powerful, because it has several million parameters, not billion, million parameters. But it is an extremely large model which you can leverage for getting the intelligence from internet. So scraping is how you start. So Google is a big scraping company, right? So all they do is scraping. They keep scraping the internet every day, every hour, and they update their repository of knowledge. And they have built a nice question answer system or nice search engine, which will extract the information from the internet and give it back to you. So what are the problems in scraping? So scraping is a slow process because you can only scrape one job or one page at a time per scraper, but you can configure hundreds of scraper. And scraping is a laborious task, and it is a bandwidth consuming task. It is basically simulating you visiting a lot of pages. That's what scraping means. So when you spend 2 hours in browsing the internet, you might have seen probably 100-150 pages, right? So that is all you can see if you have to read from it. But the scrapers would probably do 1000 pages an hour, something like that. And it just goes to random pages and downloads those pages and just keep navigating from those pages and keep downloading everything. And that's what it does. So scraping allows you to get all the data in one place, but what are you going to do with the data? That is the question. And one of the hackathon problems is asking you to do that, which says you scrape the internet and find intelligence, market intelligence for a specific topic. So let's say I want to find out which is the best selling toothpaste. I'm just making up this question. Or let's say which is the best AI program which is available. I mean, there are a lot of online edutech companies, right? Which give you the certificate programs for on AI technology. So which is the best AI technology certification program? This is one question you can ask. And how do you actually go about solving this problem? If you are a human being, you just go and read reviews, right? You just look at what people have opined about a particular program, what is the feedback they have put online. And based on the popularity of a program online, you take a call to subscribe to that program or not, right? This is called the the group psychology. So if everybody does it, we blindly believe that it is correct. Humans have that tendency. It is not necessarily correct all the time. Sometimes you get fooled also by that. And you can also tweak it. If that popularity was tweaked or meddled, then you end up getting fooled by that fake popularity. And there are companies which does that. They call it search engine optimization, SEO companies. SEO companies artificially create popularity for a particular link or a particular product or a particular concept. And there's nothing illegal here. They do it in the legal grounds only, but what they do, they manipulate. They manipulate the behavior of users. They manipulate what pages you see and stuff like that. And so that is the thin line between ethical practices and non-ethical practices. So SEO, we don't know where it fits, depending upon how the end user is going to react. So those are like some gray areas which are still unclear to a lot of fellows here. Scraping itself can be argued as unethical. For example, in Australia, the government has said Facebook and Google will have to pay a lot of money to the local newspapers for publishing their data. So newspapers are making a loss. So they went to the court, and the court gave a verdict saying, okay, you people only borrow information from the newspaper fellows, you pay them. And Google, I think, has complied. Facebook is yet to comply, I think. I read some news a week back. So who is owning that information can always put a hurdle saying you cannot scrape me, even if, although I am putting the information online, because all newspapers have an online version. So can you scrape it and use it for your own benefit? It depends. So if the newspaper owner says, no, you cannot scrape it, you cannot scrape it, because it is their property. They created that news. They published that news. So whoever publishes it will own it. But if you keep it in the public domain, can you scrape it without their consent? We don't know that. Ideally, we should take their consent before you scrape it, but people don't take it seriously. If you put it in the public domain, anybody will take it. So that is the argument people have. So there are no clear guidelines about scraping. So scraping can also be argued as illegal. But although today it is not a problem, people scrape everywhere, but it can be argued. So that's why when you scrape data, please be careful about the privacy and also the sharing rights. So when you don't blindly go and scrape a site, because you may get into trouble, because there will be an explicit mention somewhere in that page saying you cannot scrape it. This is my property. You cannot scrape my property without my consent. Although I'm putting it online, it is still my property. So you have to pay attention to that. And the other thing they do to avoid scraping is to create traps. So this is also another problem. So if you blindly navigate through the links, you may end up in a recursive loop, or you may end up in a vicious circle. So you'll be circling in one particular link or set of links that they call a spider trap. So the scraper is called a spider. Usually the program that scrapes the internet is called a spider. And there can be spider traps purposely built to avoid people coming for scraping. So if you get into a loop, then generally on the scraper side, that site will be marked as red. It will be red flag because there is a problem in that site. So they don't go and scrape again. So it's a kind of a practical setting. I'm going to skip to the place which lists the tools. Some of the things that you need to be cognizant about, or you need to be aware of before you start scraping, is these 4 areas. The document object model, which is the model with which the websites are created. So if you understand the document object model, after you scrape the data, which is predominantly HTML. So when you scrape a page, it is predominantly HTML, and HTML follows a document structure. And if you understand the document structure, it is very easy for you to extract specific information from the website. Otherwise, you may have to go and do things manually, which is going to be a pain. Or you have to train the scraper to pick the right location. You have to train it manually. And once you train it, then the scraper will do the job automatically. So training is not the AI training. You just teach the scraper to go to this location by configuring it. It's a visual training. So in the modern times, it is called robotic process automation. So in the ancient time, it is called training the bot. Now we call it RPA. RPA is a superset of scraping. So if you configure an RPA agent to go and scrape, it will scrape. An RPA agent has more power than a scraper. So scraper can only go and download pages from the web page, from a website, whereas RPA can do much more. It can also do scraping. So if you know a ready-made RPA toolkit, use that toolkit for scraping. That will make your life simple, because RPAs can do a good job in scraping. And after you scraped it, you need to validate the data. For that, you require some sort of matching logic. So this is predominantly powered by regular expressions. So if you refresh your regular expression memory, then that is going to greatly help you. And for scraping the web, you don't need to be an expert programmer. If you know basic scripting, that is more than sufficient. And there are some ready-made tools which are available, like curl and wget. These tools are available both in Linux and Windows. And you can use these tools to go and download a page directly. I mean, you don't need a browser. So curl and wget are text browsers. You can call it that way. And if you know the URL of a particular page, you just give it to curl, and curl will download that entire page for you. And you can actually find out more links in that page and pass those links to curl, and curl will continue downloading it. Or wget has a recursive download option. And if you turn it on, then wget will download the entire website for you. If the website's domain is the same, it won't download the outbound links automatically unless you configure it. But if you have the links from the same website, then wget can be configured to download the entire site in one shot. So this is a faster way of scraping a website, not a web page. So those are like very useful tools you can start building your scraper on. And there are graphical tools also available, which can be used. Portia is one very powerful tool, and in Python there is something called Scrapy. That is also a very powerful scraping agent, which you can do. And Portia can be configured. I mean, you can train which are the data points you need to get it down to your machine, or how do you validate a particular extract from a page. So this is a slide which talks about the Portia thingy. Portia is an open source. You can get it and use it without any trouble. And Portia can be configured. I mean, you can select a particular location and say, this is what I want. You can visually select and tell Portia that you extract only this field. I don't need anything else. So that is very easily doable with Portia. And there are several other tools like Portia. Portia is there for the past maybe more than a decade, because the last time I used Portia was 1.5 decades back, or maybe 1 decade back. So I'm sure there are several other variants of Portia which is available in the open world, which you can try. Yeah, with little bit of HTML experience. And so this is the illustration of why you need DOM. Because if you look at it, if you need this text node, which is pointed by the arrow, the HTML page starts with the document, and you have to traverse all the way through the tree to reach this node. So the XPath is this document/HTML/body/div/p equal to text node. So this is what we mean by DOM, the document object model. So once you understand how the HTML is programmed, then configuring your agent to extract this particular node is easy. So in Portia, you can do this visually. If you go and select this text node in the web page, Portia will show you this XPath, and you can check if the XPath is okay. And if the XPath is okay, then you can say yes, and Portia will add it to the list for scraping. So visual scraping tools are there. You can try using them. And I'm going to skip this part. So a little bit of programming knowledge, a little bit of scripting knowledge with regular expressions and tools like Portia, then you should be good enough to do reasonable web scraping. And after you scrape it, what are you going to do? That is the most important part, especially for the problem statement that was listed. All you have to do is to filter the pages based on the keywords that they might have given, and then try to see if you can draw some lines between those discrete data points collected from the website. So it will be an involved effort. So you cannot do everything automatically. So a little bit of human review needs to be done. So you need to first look at the data yourself and see how you would do it as a human being. And then once you see a pattern in your process, try to automate that pattern. So don't expect things to happen automatically. So you need to first figure out how you can collect data from the internet and how you draw lines between different information points to get the required insight. And once you understood the process, which is done manually, then see how that process can be automated using tools like Portia and other analytical tools. So that is how you can draw insights by scraping the internet, right? So that would be all about the scraping thing. And so it's already 10:30. So I'll be taking questions now if you have some. All right. Okay, there is one question from Aditya Kamath. How to advance a career in the field of AI after learning the fundamental basics? Second question is how to create good projects which will help me as an individual understand and also what the industry requires. Okay, so Aditya, my answer to you is, there are multiple ways of doing this. The number one is you need to have some practice. Before the best strategy is to do an internship in an AI company. So any company that does projects using AI, just try to seek for internship from them, because that is the best practice you will get. But to get an internship, you have to prove your worth. Otherwise, they won't talk to you. So how you can prove your worth? is by doing some hackathons online, or you can do some Kaggle assignments yourself. You can compete. You can show that you have the competitive edge. You are a competitor. That is one thing you can do. See, doing a lot of courses online and getting certificates will not help. It can only get the attention. I mean, it is just a gate pass to talk to an expert. But after you get the gate pass to talk to them, then your experience and is what is going to count. Because experts will find what you are within the first 2 minutes. If they talk to you, they will find you what are you made of in the first 2 to 5 minutes. They will easily find that. Right? So when you represent yourself, when you pitch yourself for an opportunity, whether it is internship or an employment, you should have material evidence, a lot of material evidence with you to substantiate that you are worthy. And if you don't hire me, you are at loss. That is the kind of experience you should give to the person who's speaking to you. I understand. I think you understood what I tried to say here. So if you speak to me, let's say, for example, I should feel that, okay, I should not lose this guy. Right? So you should provide enough evidence for me to get attracted to your talent. And what attracts me? Your practice experience, not your certification experience. I am more keen about whether you can get your hands dirty, whether you can solve the problem yourself. Do you have the perseverance to handle unseen problems or problems from the unknown territory? Are you trainable? Do you have a positive attitude? These are the questions I want answers. And if you can provide answers to those questions, you are already in my liking. Right? So you need to present yourself as an attractive candidate to a potential employer. Then they will take care of you. And one advice I will give you is that, don't join a company where you don't get peer support or supervisory support. Don't join a company which will not give you peer support or supervisory support for your AI career. So don't join a company which does not have an AI team. Right? They may throw a large number at you, but don't join them, because you will not learn anything. So always join a company where there is good support structure, because you are young, you are still learning. So always join a team where you can find others to help you, at least for the first 1 or 2 years. After that, you are on self-train. The first 1 or 2 years are very critical because you are setting your foundations that time. So always land in a company where you get very good peer support, and at least you get supervisor support. So find out who's going to be a supervisor. Don't think about which company you are working on. Right? Always see who are you going to work with. That is more important, because that person is going to shape your life, at least for the next 1 or 2 years. Maybe the foundation block for you. So always choose your boss or choose your leader. Don't choose the company, choose the leader. So in LinkedIn, most of the information is available about every individual who's practicing AI. Track them, reach out to them, and see if you can convince them to give you an internship. And then it is automatic. After that, the process will take care of you. You don't have to do anything more. Hope I answered your question. Okay, somebody says, Akash. Akash says, I'm good at mathematics side, but I don't know about the computer language. What steps should I take? You know the answer already, my friend. You said your mathematics is good, and you also say that your computer programming is not that good. Spend some time, learn it. If you are good at mathematics, computer programming will come like it is a no-brainer for you. It will be a no-brainer for you. Because what people do in programming is just assembling mathematical models or assembling mathematical functions. That is all they do. See, don't worry about, I cannot remember all the keywords. You don't have to remember all the keywords. Let's say when you start programming, the first one is going to be hard, because you need to use the internet or a book to write your first program. But after your 10th program, you will most likely remember all the keywords. And you always have the internet beside you to provide the necessary support, or you have a book next to you, which will also provide the necessary support. Patience and perseverance. That is all is needed to pick a programming language. And I suggest you pick up the Python language because it's very easy to learn, and you can quickly start writing programs in Python. And all the machine learning AI libraries are available in Python, so that if you pick up Python, then you will become attractive to a lot of employers already, because you said you are already good in mathematics. People who are good in mathematics and programming is a rare find, Akash. In my experience, I've rarely found people who are good in mathematics and also in programming. It's always the either or case. And if you pick up programming, which is very easy to do, you will be one of those premium candidates. So think about that, and it's in your reach. You can always take that. Okay, the next question is, like you mentioned about Kaggle, are there any such platforms for practice or just tinker around? Kaggle itself is that, man. See, Kaggle indexes all the old competitions also, along with the solutions. So the latest Kaggle competition might be open-ended. It is unsolved, but the older competitions, every data, every solution is made available. And the winning solution will also have a nice paper. The winning solution will also have a nice, I think the top 3 will have the papers also. So try to take problems from Kaggle and try to solve them yourself. And when you're not able to solve it, fine, as a final resort, go and open the top 3 papers and see what they have done, and try to mimic it and see if you can get the same scores that those teams managed to get. And that will set a lot of confidence in your motion, and then you will know what to do next yourself. You don't need external help. See, the thing is, you need to get that first confidence to take this as a path. And once you get the confidence, then you know what you should do. With a little bit of mentorship, then things will all be okay. So Kaggle is the best place to start. But I'll warn you, Kaggle is not how the world works. In real life, most of the times, you need to find out what is the research problem you have in your hand. You will be only given problems. But if there is a research component to that or not is in your purview. So Kaggle is a practice zone. I mean, it gives you a rounded problem. They give you a problem statement which is bounded, and they'll give you a nice curated data set also. And you just have to apply existing solutions to get existing techniques to get the solution. So it's a rounded environment. But in real life, it's not that sweet. In real life, the problems themselves take a lot of time to understand, and then figure out what is the research component in it, and then go with finding a solution to the research component. And this is why I said you need to have peer support, because you cannot solve it yourself. You need help from your supervisor, from your colleagues. You need help. That's why I say always join a company which has peer support or supervisory support or both. Buddy.ai has both. I'm just promoting my company here. So Buddy.ai has an R&D unit with more than 30 people, 30 seasoned researchers. And we have PhDs in the team. We have people who pursue PhDs in the team. And we have a rich research culture in the team. So I'm not persuading you to join me. If you can join us, it is great. Even otherwise, when you make a choice, always make a choice such that you join a team where you get good peer support. That's critical. Okay. Sure. I don't know if I can speak about Buddy.ai here because this forum is not meant for that. Maybe you can reach out to me offline. So my email is sudar@buddy.ai. I'm going to type it here. So please shoot an email to me. I'll be very glad to have a conversation with you, with all of you, if you want. Any other questions? Any questions pertaining to the hackathon problem statements? Okay. Shubhajit is asking, what is the qualification to join my company? Okay. See, personally, I don't believe in degree certificates. I don't care even if you have a certificate. I mean, you have a degree. I mean, I only care if you have the necessary skills to work with us. So we don't really care if you are an engineer or a postgraduate or a science grad. I don't care, as long as you can express your ideas in code. In programming, you have to express your ideas in code. That is absolutely required, because we speak in language, man. We speak in programming language, right? And in fact, we speak two languages in our company. We speak Python and Scala. So Python is for rapid application development or quick prototyping, and Scala is for enterprise development. So all our researchers do programming in two languages. Everyone does that, and that's a mandate in the team. And that gives them amazing capability of being independent. They don't need another engineer to implement their idea. They will implement it themselves and roll it to production. So that is a culture we have. So the qualification that we seek is, you need to have good understanding on the fundamentals of AI, and you should be extremely good in programming. So these are the starting points. And of course, you should be trainable and should have a positive attitude. That's a non-negotiable. And if you fit all these 4 qualities, talk to me. The languages are Python for rapid application development or quick prototyping, and Scala, S-C-A-L-A. Scala. So put it on the chat box, sorry. Scala for enterprise development. So Scala is a JVM language. So it's amazingly beautiful, I would say. I mean, I fell in love when I started learning that language. And I was a C++ person all my life. Even today, I do code in C++. And when I started Scala, I literally fell in love with that language. It's so beautifully designed. You should have a look. It's worth. Anshuman, I don't understand your question. I can't make a team for now. So can I join us? I don't understand, Anshuman. Can you ask it? Can you unmute yourself and ask it maybe? Okay. Or if you have difficulty speaking, then can you type it again? Or maybe rephrase it again? Okay. Oh, that's a different question. Sorry. So you got an answer from Craig. Okay. All right. So if there are no questions, thank you very much for the opportunity. And I wish you all good luck in solving your hackathon problems. And feel free to reach me. And if you have any questions, not only about the problem that we gave, about other problems also, I'll be glad to help in whatever way possible. Thank you very much all. And I thank the organizers. Thank you. Should I just leave, or will there be a closure? Deb or Pradeep is not there. Okay, I'll wait. So I have to wait. So if you have other questions, I'll be glad to answer. Sure, Anshuman, shoot an email. We'll speak.
Sudarshan sir, thank you so very much. We are actually honored to have you, and especially thank you for taking your time out on Sunday and empowering us and enlightening us with the uses of AI for solving business. Once again, actually, we are really honored to have you on this forum. And thank you all the participants for joining us. Sudarshan sir already has shared his email ID, so you can get in touch with him and directly if in case required. So wish you all a good night who comes under in Asia Pacific, and the other part of world have a good Sunday, good day ahead.
Thank you. Thank you, then. Thank you. Thank you. Thanks for the opportunity. Have a
My
good night.
pleasure, sir.
Have a good day. Thank you. Bye-bye.
Thank you. Bye.